Hello, my ninja warriors. What's up, everyone? How are you all? And I know that you are coming straight from the physics J booster session. Tell me how many of you are joining from physics session, and we are going to start mathematics part of it. Now, if you are following the Vedantu J English channel, you must be seeing that we have conducted a poll in the last couple of days that do you want theory session plus PYQ session, or you just want a problem solving session? Basically, where are you facing problem in? That's what we wanted to know. And you know what? You guys told us that, ma'am and sir, we want a complete theory as well as application as well as PYQ session, which will give us confidence. And we are here for you. We listen to you. We hear you. And here we are with the JEE booster session. And today's topic is matrices and determinants. Now, you must be wondering, ma'am, why matrices and determinants? So, as per the analysis, as per the trend analysis of past couple of years, you all know that there are two chapters which are trending. Number one is matrices and determinants, which we are going to do today, and tomorrow we are going to conquer, master one of the highest weightage chapter in the history of JEE mathematics, that is vector and 3D geometry. These two chapters if you are going to do now, then the whole JEE mathematics game of yours will be completely changed. Okay, these two chapters, because you know what, from matrices and determinants, 3 questions short you're going to expect in JEE Main 2026, and from vector and 3D geometry also 3 questions, 3 to sometimes 3 to 4 questions from vector also. That means these two chapters alone can give you 6 questions, approximately 6 to 7 question. Okay, 6 4s are 24 marks from the 2 chapters alone. Can you imagine? Okay, and let me tell you, when you actually, if I talk about the average paper, 48 marks means 99 percentile. So 25 alone marks in mathematics you're going to get from these two chapters. So this is going to be a major concept booster session for you. I can see that volume is a little low. Tell me now, everyone. Tell me now. Tell me now. Is my volume fine, everyone? Yes. So I can see you guys are asking a couple of questions over here. Is this video gonna cover all concepts so that we can solve all PYQs? Absolutely yes. Okay. Yes. All right. So we are going to start with matrices. Okay. So let me tell you about matrices and determinants. If I start with matrices, starting 10 to 15 minutes, I am very sorry about it, but it is going to be a little bit theory, a little bit terminologies of matrices. Okay, basically matrices is a very different chapter. If you see, the addition in matrix is very different from the normal mathematics. Multiplication is different. The conditions are different. So in the beginning 10-12 minutes, please allow me to explain you the basics terminology of matrices, so that after that there are going to be loads and loads of PYQs and application part. Okay, all right. Yes, everybody. Now, yes, you guys are talking about session duration. So session duration, I have designed this session in such a way that we'll be completing the session in approximately 3 hours, plus minus 10-15 minutes will be there. And you know what, trust me, now because only 66 days are remaining for your JEE Main 2026, please do not message, please do not write in the chat box, ma'am, what's the duration? Ma'am, we are studying from since so many hours. Everybody is putting hard work. You too have put hard work. Okay, you have no option. And I am also putting my hard works. I am also putting my nights. So let's set the target approximately 12. Before 12:30, I will finish the session, that I can assure you. Okay, do not worry about it. Make sure that you smash the like button right away. Okay, yes, smash the like button right away. Everybody, yes, okie dokie. Have you liked my session, right? Can we start now because we don't want to get late? And by 12:30, we'll be finishing it. And you know what? By 12:30, if you give me these 3 hours, right? There will be one short break also. But if you're going to give me these 3 hours, what I am going to give you in return is full confidence in matrices and determinant chapter. I am going to tell you that from where high frequency, which topic is a high frequency topic, which topic is a hot topic, and from which topic you can expect maximum number of questions in JEE Main 2026. Okay? Yes, absolutely. This session will be helpful for boards, but if you are solely watching this for boards, that trigger warning, that your brain might get triggered because a lot of JEE Main PYQs will be there whose level is very different from boards. Okay, so only the theory part will coincide with your board section, right? But the questions will not overlap. Here it is completely JEE Main oriented session. Okay, all right. Let's start everybody. Enough of hype over here. Let's quickly start. Okay. So we'll start with very scratch. Even if you do not know about matrices, don't worry about it. All I want is honest and undivided, undistracted attention of yours in these 3 hours. If you can give me, I can assure you that every aspect, every topic of matrices and determinants you will get. Okay, and every question in this session you will get. Okay, all right. I want to see some fire emojis in the chat box because I want that you should feel that, okay, ma'am, after 66 days, we are about to give JEE Main and we want to become confident on that day that yes, at least these many chapters, so I am very confident with. Okay, all right, everybody. Yes, let's start. Okay, now what is a matrix and what is a determinant? Determinant, we'll talk about it a little later. Right now, let's focus on what is a matrix. Okay, so matrix is nothing but a rectangular arrangement of m into n number. Okay, so can you see that a matrix is denoted by capital letter A, and you might be seeing capital letters also matrices is given. Okay, if you see the question. Now in matrix, what will be there? There will be number of rows and there will be number of column. So when there are number of rows and number of column, that means it would be a rectangular arrangement. So it will be a rectangular arrangement of mn numbers where m is nothing but number of rows. Can you see the horizontal ones are number of rows? This is row number first, row 1. This is row number second, row number 3, and all the way up to row number m. Okay, the horizontal ones are row. And the vertical, column number 1, column number 2, column number 3, column number 4. Okay, all right. So this is how your matrix will look like. Okay, correct. Now, just one thing. Suppose I am creating a matrix. This is A11, A12, A13, A21, A22, A23, A31, A32, A33. Correct? Can you tell me that how many elements are there in this particular matrix? Ma'am, I can see row 1, row 2, row 3. Ma'am, 3 rows and 3 columns. So 3 rows, 3 cross 3. Okay. What is 3 cross 3? 3 cross 3 is nothing but order of a matrix where this 3 represent row and this 3 represent columns. Okay. Yes, row and column. Let me zoom out a little bit because I can see that part is not that visible. Now I think it is visible. Okay, and a little bit like this also. Absolutely. Okay, are you getting this point? Number of rows, number of columns. Okay, and there is one more terminology which is involved with matrices, which you all should know is nothing but order of a matrix. Yes, order of a matrix. Can you see order of a matrix? What is order of a matrix? Order of matrix is nothing but number of rows multiply number of columns. Okay, so number of rows you have to count horizontal. How many horizontal linings are there? So number of rows cross number of columns, okay? And also one more thing, if you can observe over here, any element, there is a way of representing an element also, okay? So over here, if you see, what is this? Can you see this is, ma'am? This is A32. What is A32? A32 means this element is sitting in third row and second column. Okay, so element itself is telling you that, oh, I am sitting in third row and second column. Can you see? First row, second row, third row. Yes, ma'am. This element is sitting in third row. First column, second column. Yes, ma'am. A32 means which column? Second column. Okay. Now just tell me one thing, if you can understand it. A43 will sit where in this determinant? Can you tell me what's the position of A43? A43 position. So ma'am, A43 will be fourth row. So row number 1, row number 2, row number 3 and row number 4. So fourth row and third column. So column number 1, column number 2, column number 3. So A43 will be here. Okay. So this is row 1, row 2, row 3 and this is row 4. So it is sitting in row 4 and C1, C2 and C3 sitting in column number 3. So basically, if you know the element name A57, you can actually create that position also. Okay, so Aij, what is Aij? Aij means element sitting in ith row, okay, and jth column. Are you getting my point? Yes, okay. So chalo, if you are getting this point now, can you do a little bit quick question will do. Quick question, okay. Very quick question. I'm not going to take much time. Construct a 2 cross 3 matrix. Okay. So A, 2, 3. Okay. 2 cross 3. First of all, what is 2 cross 3, ma'am? This is order of that matrix. That means there will be a matrix, okay, whose number of rows are 2. Row 1, row 2. Basically only 2 rows, but column will be 3. So row 1, row 2, 2 cross 3 will look like this. Okay. Now this is A11. A12, A12, A13, okay, A21, A22, A23, correct? This is how your matrix is going to look like. Alright. Now quickly let me know that A11, what will be A11? So ma'am, A11 will be 1 plus 2 into 1 by 3. So 3 by 3, that is 1. So this is just 1. A12, can you tell me what is A12? So ma'am, A12 is going to be 1 plus 2 2s are 4 by 3. So ma'am, 5 by 3. What about A13? So now 1 plus 6, 7 by 3. Okay, 7 by 3. So basically what was happening? 3 by 3, 5 by 3, 7 by 3. Now A21. So this is 2 plus 2, 4 by 3. Okay, now this is 2 plus 4. 2 plus 4, 6 by 3. 6 by 3 is 2. And 2 plus 6. 2 plus 6, 8 by 3. Okay. Alright. So this is, ma'am, this is how the matrix is going to be. Okay, easy peasy. I don't think so that this is going to be any problem over here. Now one question, one elementary question again. Okay, let's do one more elementary question because now we have to level up also. Let's see that how many of you can actually answer this easy peasy lemon squeezy question. Okay, so it is going to be if a matrix is having 12 elements, okay, then what are the possible orders it can have? Orders, 12 elements. So ma'am, you told us that mn elements are there in any matrix, okay. So m cross n could be the order. So basically 12 elements are there. So first case that it could be 12 cross 1 and 1 cross 12. That means it will be having 12. Camera focus is going kya? Is it a trouble? Okay, if it is going to happen again, we'll see. 12 rows. Okay, so 12 rows and only single column. So it will be A11, A21 and all the way up to A12-1. Like that. Okay. Now third it will be 2 cross 6. Fourth it will be 6 cross 2. Fifth, it will be 3 cross 4, and sixth, it will be 4 cross 3. Okay, is it correct? Can you find any other matrix also? Yes, I think 6 are there. Okay, 6 are there. Okay, yes everyone, I think Kyotaka is absolutely right. Have I missed anything? Let me know. I don't think so. Okay, chalo. Now let's focus on some definitions. Ready for some definitions? Okay, now give me 5-7 minutes, because 5-7 minutes no questions, straight theory, but I promise after 7 minutes there will be loads of questions. Okay, but you have to listen to that theory, 7-minute theory, so that you can attempt those PYQs. Okay, yes, clear? Alrighty, alright. Now types of matrix. Number one, row matrix, also known as row vector, but popularly known as row matrix, which is having only single row. See over here, if I go back, can you see that this is having single row? One row but 12 columns. Oops, what happened? Oh no. Oh no. Okay. Actually, my smartboard wire got a little bit. Oops, now it will get started again. It will start again. Okay, so it will take 2 minutes. 2 more minutes. Okay. Chalo, it will take some time. I will. Not more than 1 minute. I think it takes 1 minute only. No, actually, this is not good. I think I should reload that file. See, countdown. Countdown has begun. Can you see? 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Manifest 99 percentile in JEE main. 54, 55, 56. Are you manifesting? Meanwhile, can you just write your which state you are coming from? Which state you are coming from? 84, 85. Countdown for 99 percentile. Yes, absolutely. Kerala, great. Tamil Nadu, so many people from Tamil Nadu, huh? Palakkad, okay. Is that a place? Tamil Nadu collab with London. Andhra Pradesh. Karnataka, okay. Tamil Nadu competition is there, huh? Tamil Nadu is giving tough competition to everyone, kya? So last 10 slides are there. Kashmir, is it? I am actually from the middle of India. Yes. Okay, so we are back to our thing. Okay. So yes, row matrix which is having single row, column matrix which is having single column. So row matrix would look like what? Row matrix would look like what? This is row matrix, single row. Column matrix will look like this. Okay. Yes, everyone. Now we have zero matrix or null matrix. What is zero matrix or null matrix? Zero matrix says that all the elements are zero. Okay, that's it. All the elements should be zero. Okay, no element should be non-zero. Every element is zero. Null matrix, as simple as that. Okay, yes, everyone. Now, what is a square matrix? What is a square matrix? Think about it. Square matrix which looks like a square. What is a square? Ma'am, sides are equal, length and breadth are equal. So here number of rows is equal to number of columns. Can you see? Number of rows and number of columns when become equal, it is a square matrix. And one very important part or term related to square matrix is known as diagonal of a matrix and trace of a matrix. Okay, I am telling you, very important, diagonal of a matrix and trace of a matrix. Now see, if I create a 3 cross 3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33. Correct? Now understand one thing, that what is happening over here is this thing is very unique. These three elements are very, very unique. Okay. Why are they unique? Because here A11 is first row and first column position. A22 is second row, second column. A33 third row, third column. Basically, we can say that this is Aij where I and J becomes equal. So this is going to be the principal diagonal, not the other one, not the other one. Because you know what, in square, if you talk about the geometry, this is also a diagonal. Ma'am, this is also a diagonal. But no. Okay, so in matrix, this is a principal diagonal and this is not, we will not consider that this one is a diagonal. Only this one. Okay, understood? Correct? Now, the moment you know the diagonal, you should know what is the trace of a matrix. Trace means sum of all the elements in the principal diagonal. Sum of all the elements in the principal diagonal. Basically, trace of any matrix A is A11 plus A22 plus A33 and so on, all the way up to ANN. It depends. Okay. Alrighty, everybody. Clear? Correct. Okay. Now, let's talk about square matrix. Okay. I'll tell you which definition is very important and which definition is okay, important. Okay. Yes. Square matrix. What is a square matrix, ma'am? Number of rows and number of columns are equal. Okay. Now, square matrix are having one thing which is Diagonal matrix. Diagonal matrix is nothing but a type of a square matrix whose non-diagonal elements are 0. So diagonal matrix means it is a square matrix whose non-diagonal elements are 0. Okay, understand. So can you see this is diagonal matrix because can you see non-diagonal elements? Can you see non-diagonal elements? Non-diagonal elements all should be 0. If it is happening, then it is a diagonal matrix. Then we have scalar matrix. What is a scalar matrix? Scalar matrix, ma'am, it is a diagonal matrix only. Where non-diagonal elements, ma'am, you can see are 0 only, but here the diagonal elements are all equal to A. So here, what is a scalar matrix? Ma'am, scalar matrix is nothing but a square matrix whose non-diagonal elements are equal, but diagonal elements are same. Let's say A. This is what a definition is, okay? And there is one very important type of this, which is nothing but identity or unit matrix. What is identity matrix? What is unit matrix? Unit matrix is nothing but a scalar matrix only, or you can say a diagonal matrix only, or you can say a square matrix only. So a diagonal matrix whose all diagonal elements are equal to 1 unit, right? So identity matrix is denoted by I. Since it is a square matrix, it could be 2 cross 2, 3 cross 3, 4 cross 4. Here diagonal elements is 1 and non-diagonal would be 0. This is your I2. I2 means identity matrix of order 2. Correct? Okay, getting it? Yes? Alright. So now you understand one by one what is a square matrix, number of column, number of row equal. What is a diagonal matrix? Diagonal matrix is nothing but non-diagonal elements are 0. Also, if I have to tell you that there is a diagonal matrix, I will be like A is equals to diagonal 3, 0, 1. So you will be like, okay, what is this given? This is a full-fledged diagonal matrix whose 3 elements are given to you. And now you know that the non-diagonal one to would be 0 na automatically. So you can fill 0. Okay, getting it? Getting this point? Alright. So this is your diagonal, correct? This is scalar matrix. In scalar matrix, what happens? That suppose 3 cross 3 scalar matrix. So here non-diagonal elements are 0. Okay, non-diagonal elements are 0 and the diagonal will be same, A. This is scalar. And unit matrix, so we have seen, correct? Okay, alright. So this part is very important. This is little important, not too much important. What is this? So triangular matrix, can you see here that square matrix is having another type. One is diagonal, another is triangular matrix in which upper and lower triangular are 2 types. Upper triangular means that the elements below diagonal should be 0. Reverse thing. Okay, understand the definition nicely. What I am trying to say is elements below the diagonal should be 0 in upper triangular matrix and elements above diagonal are 0 in lower triangular matrix. This is okay important, not too much important. Okay, but you should be aware about the definition. Okay, clear? Alright, so definitions are going on. Now let's get into some mathematics part, algebra of mathematics, how to add, how to subtract, how to multiply, etc. etc. Are we ready? Yes. So now addition or subtraction. So it's very easy. If you want to add 2 matrix, first of all their orders should be same. Then only they can be added. Just like suppose I ask you add x and x square. So you'll be like, ma'am, x plus x square, so we can't add, no? It will remain like this. We can't add because like terms are not there. They are not like terms. Although 2x and 3x can be added, 2x plus 3x is 5x. Why? Because they were like terms. So here also like terms are there. So 2 matrix can be added or can be subtracted only if their only if their order becomes same. So I think This is nothing very rocket science. I don't want to talk about it anymore. It's just that some properties you need to know, that A plus B is equals to B plus A. Same as mathematics, na? 2 plus 3, 3 plus 2, both are equal. So basically matrix addition follows commutative property. That's what I want to say. But you know what? A minus B and B minus, obviously they are not equal. 3 minus 2, 2 minus 3 not equal, right? Okay, so this is also like this. Okay, then A plus 0 and 0 plus A, correct? So A plus, what is this? 0, 0 is null matrix. So A plus null is equals to null plus A is just A. Same. 5 plus 0, 0 plus 5. Here 0 is not 0 but 0 is null matrix. Okay. And you know what? A minus A is null matrix. So again, I think this is following normal matrix property. So I don't have to spend so much time in that. Now, multiplication of matrix by a scalar. Suppose you have an A matrix 2, 0, 5, 1, 2, 3. Correct? Now you want to multiply 7. You want 7A. So now 7A you want to multiply. So you have to multiply 7 in each and every term of this matrix, and eventually you will get 14, 0, 35, 7, 14, 21. This is your 7A. Okay. Alright, clear? Not a very difficult thing. Okay. Now some matrix multiplication over here. Yes. So it is K times A is equals to A times K. K is a scalar like 7A like we did. Okay. Again, this, if you are multiplying K in sum of two matrix, it will be Ka plus Kb. Very easy. Okay. And this is the self-explanatory. This is also self-explanatory. Okay. So I think scalar multiplication would not be a concern. Now this is something which is very, very, very important. Okay. Yes. Rajkumar wants to solve questions first. See, what I have observed, let me tell you, Rajkumar, when I teach you theory, you people, I am not talking about myself, I am talking about you people. When I teach theory, you always come and ask me that, ma'am, no theory, please solve questions, only PYQs, no theory, okay. And then when I start solving problem, you just take a step back and you just watch it and you just get mind blown by the problem, overwhelmed by the problem, and start writing, ma'am, theory is clear but a problem not happening. Tell me, you do this or not? You do this or not? Okay, so only once we are studying theory in the whole year. In the whole year, only once we have to study the theory. But you don't study theory because you are chanchal prani. What is chanchal prani? You don't have patience. Have some patience, because this session, I know this file. I have created this file for you, and trust me, there are so many questions. I was putting the so many questions and I was like, these students will be able to handle these many mathematics questions or not. Okay. And in the beginning only I told you there is some theory. There is some theory. Just for in the beginning, just hold on that patience in the beginning, understand that theory, and then eventually so many problems will be there. PYQs. Okay. Chalo. Now have some patience. Okay. Chalo. Abhi two matrix. Ouch. We are going to multiply two matrix. Okay. So how to multiply two matrix? First of all, when exactly the matrix multiplication is possible? So product of two matrix is only possible where suppose A matrix and B matrix. Okay. A matrix is M cross N and B matrix is having an order of P cross M. Okay. This is order of A, this is order of B. Now product AB will exist or not, that we have to figure out. So product AB will exist if number of column of A, number of column. What is number of column? Hold on, this is N cross M. This is M cross N and this is your N cross P. Yes. Number of column of A. Can you tell me how many columns A is having? So ma'am, A is N. should be equal to number of row of B. Number of row of B is this. Can you see they are same? If they are same, then yes, product will exist. Got it, everybody? Product will exist. So you have to understand. Product will exist. Okay. Now one more thing. Okay. That now finally you will figure out, because AB you can multiply two matrix. What will be the order of AB? Can anybody tell me order of AB? So order of AB will be equal to number of row of A cross number of column of B. Okay, please understand matrix multiplication very nicely, very detailed, minutely. So number of row of A. So ma'am, number of row of A is M and number of column of B is P. That means M cross P will be your order of AB. Okay. So this is the theory part of it. Now let's focus on the application part of it. So I will give you two matrix. Okay. A matrix over here is 2, 3, 4, 7, 9, 8. B matrix will be 7, 0, 1, 3, 0, 5. Okay. Now you have to tell me whether AB will exist or not. Okay. Tell me, AB will exist or not. And if it is existing, then also tell me what will be the order of AB. So let's check, everyone. A matrix, ma'am, 2 cross 3. Okay. B matrix, ma'am, 3 cross 2. As per the product rule, Ninja ma'am told that number of column of first matrix should be equal to number of row of second matrix. So ma'am, this and this is same. So yes, this will exist. Okay. What will be the order? Tell me, ma'am. 2 cross 2 will be the final order. So let us figure out AB. Now, how to multiply? Okay. Everyone, please watch me, because so many matrix multiplication question will be there in JEE Main 2026. I will show it to you. Okay. So how to multiply? See, AB you have to multiply. So row number 1 will get multiplied with column number 1. So 7 2s are 14, 3 1s are 3, 4 0s are 0. So 14 plus 3 plus 0. 14 plus 3 plus 0. Are you able to see? Yes. Row number 1, column number 1 done. Now row number 1 is fixed, column number 2. So 0 plus 9 plus 20. So this is 0 plus 9 plus 20. Okay. Now what about this? This row 1, column 1 done. Row 1, column 2 done. Now focus on row number 2 from here. Row number 2 will get multiplied with column number 1. 7 7s are 49 plus 9 plus 0. So 49 plus 9 plus 0. And now the last row 2, column 2. So this is 0, 27, 40. So 0 plus 27 plus 40. So AB is nothing but 17, 29 and 58, and you have 57, 2 crossed. Okay. Now I will not do further multiplication. This is done and dusted for you. Okay. You can multiply any two matrix with this given approach. Okay. Now one thing, tell me, will BA exist or not? BA exist or not? Question. Tell me, BA exist or not? BA, ma'am, BA के लिए, so B is first matrix. That means number of column of first should be equal to number of row of second. Yes, ma'am. Yes. This is also existing. And you know what? BA order will be 3 cross 3. Order of BA will be what? 3 cross 3. Correct or not? What does that mean? That simply gives me a property of matrix, property of multiplication. Yes, this one. In general, AB and BA are not equal. In fact, sometimes your AB will exist, but BA will not exist. So in some cases, you will find AB will exist, but BA will not exist. Okay. So in general, AB and BA are not equal. If you multiply A with null matrix, then you will get a null matrix. If you multiply identity matrix and A, you will get A. So this is how it is. Okay. Yes. Clear? So this is how it is. Now let's solve one question. I think you are craving for one question. So I think we can start solving a couple of questions. Ready for it kya? Chalo, let's do this question. Quickly, you have to solve it. Yes, where are you, Rajkumar? Are you here? Rajkumar here? Because some people were asking about questions. Where are the questions, ma'am? Where are the questions, ma'am? Yes. So first of all, what we will do is, either you can go with FC. You can't change the order. You can't say, ma'am, I'll multiply this with this. No. Either you multiply these two or you multiply these two. Okay. So let's multiply these two. Ma'am, row 1, column 1. Row 1, column 1. 2x. And so I am going to multiply this. See, this is what? 1 cross 2. And this is 2 cross 2. Can you see? 2, 2 same. And 1 cross 2 will be the final thing. Okay, so this is row 1 into column 1. Tell me, 2x minus 9. And this multiply this. 2 2s are 4x and 0. Okay. And this is x and 3 is equals to 0. Now, row 1 and column 1. So 2x minus 9 into x. This multiply this. So x into 2x minus 9 and 4x into 3 plus 12x is equals to 0. X, if you take it out, it will be 2x minus 9 plus 12 is equals to 0. And x, this is 2x plus 3 is equals to 0. X is equals to 0 comma minus 3 by 2. So option D and A both are correct. Yes? Okay. Now you must be thinking, ma'am, JEE main to don't give. Then the value of x, JEE main 2019. So both are correct, right? So I think there is something that JEE main should think. I don't know. I mean, this is not JEE main question. Sorry. This is not JEE main 2019 question. Sorry, this is not a JEE main PYQ. Okay. All right. Anyway, now let's talk about square matrix. Okay. Let's talk about power of a square matrix. So basically, power of a square matrix is similar to exponents, laws of exponents. Remember 2 power m, 2 power n. Tell me, ma'am, 2 power m plus n. Can you see this is following the same laws of exponent? If you multiply a, how many times? N times it will be a power n. A square is a dot a. Okay, very easy things. Okay, I think this is self-explanatory, but now I am here with my ninja style. Are you ready for the magic? Everyone, are you ready for the ninja technique? Ninja technique ready? How many of you are ready? Ready in the chat box. Okie dokie, yes. Chalo. Let's start with ninja technique. So ninja technique says that there are two special matrix, which is this. Okay. Cos theta minus sin theta, cos theta. Or it could be like this also. Cos theta minus sin theta and sin theta, cos theta. Can anybody tell me what will be a square in this case? Okay. If you try to find out a square, it will be cos theta minus sin theta Sine theta, cos theta, correct? One more time, that's how we multiply. A square is A into A. Cos theta minus sine theta, cos theta. Okay. See, what's the ninja style over here? Let me show it to you. What's the ninja observation? Ninja ma'am always observes, and ninja ma'am observes and think ki acha, is it happening? Is it some pattern? Can I tell it to my students and become a ninja style? Okay. So A square, now it will be row 1 and column 1. Tell me. See, cos square minus sine square. So this is cos square theta minus sine square theta. Multiply fast. Row 1, column 2. So minus cos sine and minus cos sine. So minus 2 sine theta cos theta. This is again sine cos, so plus 2 sine theta cos theta. And last, this multiply this minus sine square plus cos square. So minus sine square plus cos square is cos square minus sine square. Can you see it? How many of you can see it? This is cos square minus sine square, cos 2 theta. Okay. And 2 sine theta cos theta is sine 2 theta. Okay. This is A square. Okay. Alright. Are you understanding my point? Two special matrix. Two special matrix says that if these two matrix are given to you, A power n will be cos n theta minus sine n theta. See, sine is also getting reflected. I took minus sign, so minus sign is here. And this is what? Minus sine n theta and cos n theta. No need to multiply. Just remember these two special matrix. Okay? Yes? Alright. If you are able to understand, then this question would be a cakewalk for you. Huh? Less than 10 seconds with the ninja technique. Who can do that? Who can do that? Less than 10 seconds with the ninja technique. Ready, ready, ready. Yes, ma'am. A is given. Ma'am, this is that ninja matrix. Ninja matrix spotted. Ninja matrix. Huh? Magic matrix. A power 32 they are talking about, ma'am. A power 32 will be cos 32 alpha minus sine 32 alpha, sine 32 alpha, cos 32 alpha is equal to this matrix. So cos 32 is 0 and sine 32 is 1. Cos 32 alpha is 0 and sine 32 alpha is 1. Tell me, when exactly your cos theta is 0 and sine theta is 1? Ma'am, when theta is pi by 2, that means 32 alpha should be pi by 2. It should satisfy. So alpha will be pi by 64. Now this is JEE Main April attempt 2019 question for you. Yes, Veera level happened. Yes, so many ninja techniques for you in this session, throughout the session. Okay, all you have to just stay with me. Okay, alrighty. Yes, another thing. Okay, now again, suppose A matrix is given to us. See, I'll give you a question, I'll solve you, I'll show you what is the ninja technique behind it. Suppose A is a diagonal matrix. Suppose A is a diagonal matrix which is 2, 3 and 1. Okay, this is diagonal matrix is given. Now if they are asking A power 10. So what will you do? A power 10. Can you see, if you are going to sit in examination hall, JEE Main 2026, you'll be like, oh, I need to multiply this matrix 10 times. So you'll be like, oh my goodness, 10 times, who is going to multiply? It is going to take bonkers. Now, I think I should sit with JEE Main 2027 aspirants also. Then only I'll be able to finish this matrix. But you know what? Ninja Ma'am is here. All you have to do is just write 2 power 10, 3 power 10, 1 power 10 and everything rest is 0. So basically, first thing which we have learnt over here is that if A is a diagonal matrix, then A power n would be A power k would be a diagonal matrix only. And you know what? Just apply the power in the diagonal elements and you will be done. Okay, clear. Yes. All right. Chalo, are we ready for another question on your screen? Ready for another question. Okay, not this one, not right now. Okay, we are not ready for it. Sorry. I think we should go for this. Yes, we should go for this. All right. Yes. So, ma'am, there is a matrix given. This is JEE 2025 problem. Huh? You know what? I sometimes feel that sometimes, you know what, when you work and you keep on working and you keep on working so much that your brain stops braining and your psychic powers get activated. Huh? So when I sleep sometimes na, all the questions actually play in my mind, the screenshot of the questions. And sometimes it happens, my psychic ability says that JEE Main 2026 question. So in my dream, there are some questions which are there, which I can predict, which can come in JEE Main 2026. All I have to do is I just have to wake up in the morning, okay, 5 o'clock, 4 o'clock, and I should just keep writing that JEE Main 2026. What is written in that screenshot? I could remember that dream and I can just write. Huh? If it happens, then I will make a close group of students. I can't do it on YouTube, and I'll do that tarot card reading, psychic reading. Na? So I'll be like JEE Main 2026 reading. Huh? I'll do that. Huh? And I'll circulate a form if anybody is interested in that session. No? What all questions can come in JEE Main. So that I will only call those students. Chalo. Back to basics, everybody. A is a matrix of order 3 cross 3. Okay. And you know what? Aij is given to you. The sum of all elements in the third row of A square. So basically, first of all, they are giving a formula of creating my 3 cross 3 matrix. Okay. And eventually, I need to create A square. Okay. A square I have to create. Once A square I will create, I am only interested in third row of A square. First of all, I need to create A matrix. Tell me, what will be A11? So, ma'am, A11 will be root 2, 1 plus 1, 2. So, that is 2. So, A11 will be 2. Now, you know what? Apply your brain. In each and every term, only root 2 will get multiplied. So, 2, 2 root 2 and 4. What will be A21? So, ma'am, A21 will be root 2, 2 plus 1, 3, so 2 root 2. So, it starts with 2 root 2 and then each and every term root 2 will get multiplied. What about A31? Okay, so A31 will be just 2. 4. Yes. So, 4 root 2 and 8. Correct. Now, you want A square. If you want A square, so you have to write one more A over here. Pure multiplication question, right? Just focus on the calculation part. I think this question is not that difficult. Now, what do you want? You want third row, ma'am. Third row. So, A square, third row we are looking for. Be very smart, absolutely smart. Do not calculate first row, second row. We are not interested. How to get third row? So, third row we will get. See, first row, how will we get? Ma'am, first row means row 1, column 1, row 1, column 2, row 1, column 3. That's how first row will get. Now, row 2. So, row 2, column 1, row 2, column 2, row 3, column 3. Okay. That's how second row will get. Now I am interested in third row. Row 3, column 1, multiply. 4 2s are 8. Okay. So 4 2s are 8. Again. Okay. So 4 2s are, so here it will be what? 8. 4 2s are 8. 8 into 2, 16. And you know what? See this into this. Now 8 4s are 32. This is this element which you're going to get over here. Okay. Now what about this element? Can anybody tell me about this element? Okay. So ma'am, this multiply this. 4 2s are 8 root 2, 16 root 2, 32 root 2. 8, 16, 32 root 2. So again 8 plus 16 plus 32 root 2. And the third element you will get by multiplying this with this. 4 4s are 16. 4 4s are 16. 16 into 2, 32. And 8 8s are 64. Okay, now sum of all the elements. Tell me. 16 plus 8 is 24. 24 plus 32 is 56. 56 plus 56 root 2. Second element. First element, second element, now third. So this is going to be 48 plus 64. 48 plus 64, anybody? So this is going to be 120, 112, right? Yes, 112 plus 112. Okay, this is what we are going to get. Now, if you add these two also, 8, 11 plus 5, 168 plus 56 root 2. If you compare it with alpha plus beta root 2, alpha plus beta root 2, alpha is 168 and beta is 56. Correct? So 224, I think you guys are absolutely right. Option D is absolutely correct. JEE Main 2025, everyone. Okay? Yes? Clear, everyone? 224, absolutely right. So you have to do the smart work, my dear students. You have to do the smart work. Okay? Now, how many of you were expecting that, ma'am, ho sakta hai, ma'am, it could be possible that Ninja ma'am in JEE Booster series might take binomial theorem. How many of you were expecting binomial theorem? Let me tell you that suppose I plus a power n, if I have to open this expression, okay, so we'll take the help of binomial theorem. How come? So this is your n, correct? So this is going to be nc0, I power n minus 0 and a power 0 plus nc1, I power n minus 1, a power 1 and so on. See, so this is nc0 and plus nc1a plus nc2a square plus nc3a cube and finally it will be ncn a power n. Okay, so that's how you're going to open this type of expression. Okay, yes. Now we have a JEE Main PYQ based on this particular thing. If you can see the question and if you can understand what I'm trying to tell you. A matrix is given to you, determinant A is given as 0. A little bit determinant, so I think that you are aware. Determinant A of a 2 cross 2 matrix, alpha beta plus 6 should be 0. That means alpha beta is minus 6. And you know what? Alpha plus beta is equals to 1 also given. Can you actually tell me that the value of alpha and beta we can actually calculate from here, and you don't have to solve the equation, just observation will give you alpha and beta. First of all, alpha is positive. Okay. So if alpha is 3 and beta is minus 2, then both equation will get satisfied. So I can see alpha 3, beta minus 2. That means we have A matrix, so ma'am we are having. A matrix, so we are having. Then the matrix I plus A power 8. Okay ma'am, so you told us I plus 8C0. So I plus A power 8 is 8C0 plus 8C1A plus 8C2A square plus 8C3A cube plus 8C4A power 4 plus 8C5 A power 5 plus 8C6 A power 6 plus 8C7 8 power 7 plus 8C8 A power 8. Okay. So what does that mean, ma'am? Please don't bully us, ma'am. Are you saying that we are going to calculate A power 8? 8 times multiplication. Are you expecting this from us? Again, Ma'am, we'll start calculating this matrix A power 8 and we'll finish in next year JEE Main 2027 January attempt. Okay, so please, I am not wanting you to this. Understand the pattern. This is pattern based multiplication, my dear students. The topic pattern based multiplication, NTA's favorite topic, has been started. So what is that? So basically all you have to do is find out A square. What is A square? Can anybody tell me? So ma'am, multiply and find A square. So this is 3 minus 1, 6 minus 2. 3 minus 1, 6 minus 2. Okay. A square. Correct. Ma'am, this is 3. So 3 3s are 9 minus 6. 3. Okay. This multiply this is 3 3s are 9 minus 6. This multiply this minus 3 plus 2. Minus 3 plus 2, ma'am, minus 1. Okay, now this multiply 6 3s are 18 minus 12. 18 minus 12, ma'am, 6. And last, this multiply this. So it is going to give you minus 6 and plus 2. Minus 6 plus 2. Minus 6 plus 4. Minus 6 plus 4, ma'am, minus 2. Oh my goodness. A square is coming out as A. A square is coming out as A. Okay, hold on. So what about A cube, ma'am? A cube is what? Ma'am, A square into A. And you know what? A square is A. So this is A dot A, which is A square, which is again A. What does that mean? Ma'am, actually, A power n will be just A. So what does that mean? This A power 1, this is also A power 1, this is also A power 1, 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 A power 1. So all the powers you can remove because A square is A cube is A power 4, A power 5, A power 6, 7, 8, all these things are A. So just take A out. And now this is 8C0 plus 8C1 and all the way up to 8C8. Remember, what is the formula of NC0 plus NC1 plus NC2 all the way up to NCN? This is 2 power 8. So 2 power 8 into A. What is 2 power 8? Can anybody tell me? 2 power 8. So 2 power 8. 2 power 8 will be, see, 2 power 5 is 32, 2 power 6 is 64, 2 power 7 128, 2 power 8 256. So this is 256 multiply A. This is your answer. 256 multiply A. So 256 multiply 3. Okay, so what is A? A is this matrix, na? 3 minus 1. Am I doing something wrong? A to is there. Then the matrix, correct. Power 8. A have taken outside. 256 and then multiply it with A. Correct? So it is going to give me, wait a minute. Alright, maybe I have made a mistake over here. Sorry. Yes. So here it is. Okay. Here it is 8C0 into I and after this. So this is just I plus, can you see this is nothing but A if you take common from here. Second term onwards you are going to take A. Yes. This is what you're getting. Okay. I got carried away. Now what about this? So ma'am, this is 2 power 8 minus 1 because 8C0 is missing now. So 2 power 8 minus 1. Okay. So now I plus A times this is 255. Yes. So now this is what? 1001 plus 255A. What is A? 3 minus 1, 6 and minus 2. Okay. If you're going to solve it, the answer would be what? Option D. Yes. 255 into 3 plus 1. Tell me. 255 into 3 plus 1. 15, 6, 765 plus 1. Tell me. 667. 766. Can you see only this thing is matching? Give me a big thumbs up. Yes. Thank you so much, Vijay Vajrak, Vajrak Rubru. Yes. Okay. So JEE Main 2025 question, pattern based question, done and dusted. Are we ready for next question? JEE Main 2022 pattern based question. Everyone, pattern based question. Ready for it? Yes. Again, see, Aij is given to you and they are talking about a square a cube. Okay. First of all, let's create a matrix. Everyone, a matrix. So, ma'am, a matrix will be A11, 2 power 0. A12. So, 2 power 2 minus 1. So, 2. Correct? This is 2 square. Now, what about A21? So, A21 is 1 by 2, 2 power minus 1 and then keep on increasing the power of 2. So, 2 power 0, minus 1, 0 and then 2. Okay, this is 2 power minus 2, 2 power minus 1 and that's it 1. So, this is your A matrix. Correct? Now, if you figure out A square, let's figure out A square. Let's do that. 1, 2, 2 square. Okay, this is 2 power minus 1. 2 power 0, this is 1. This is also 1, okay, 2. 2 power minus 2, 2 power minus 1, 1. I hope that things are visible for you. If not, I can just do this. Okay. Now, let's see A square. What is happening to A square? Pattern based question. Keep an observation also. Okay, that what is going to make, what pattern it's going to become. And you know what? Some 3 is, I can see 3 also. And you know what? One more thing. Can you see, if you observe this, don't you think that is a GP is going on. Some GP related thing is going on. Especially in B and C option, geometric progression we can observe. Okay, anyway. Over here, so this is row 1 and column 1. So 1 and then 1 and then 1. Okay, so this is coming out as 3. Good. Okay. Now what about this? This multiply this. 2, 2 and 2. So 2 plus 2 plus 2 is 6. So this is 3 into 2. This is 3 into 1, 3 into 2. Now this multiply this. So 2 square, 2 square, 2 square. So 3 into 2 square. Okay, we are getting it. Somehow I am getting it. Okay. Now row number 2, column number 1. Can you see 2 power minus 1, 2 power minus 1? 3 into 2 power minus 1. Now we are getting it. Can you see? This is 3 into 1. 3 into 2. Okay. This is 3 into 2 power minus 2. 3 into 2 power minus 1. And 3 into 1. Can you see? The moment I told you now how to multiply a scalar quantity inside a matrix. Now how to take scalar quantity common. So if you take 3 common, that means this, every 3 will come out and it will become what? Can you see what is this? This is just your A matrix. Okay. So A square is coming out as 3A. A square is coming out as 3A. Okay. Hold on. A square, ma'am, is coming out as 3A. What about A cube? Do you want to multiply A cube? You don't have to. Why? Because A square into A. Now what is A square, ma'am? A square is 3A. So 3A into A. So 3A square. A square is again 3. So 3 square A. So A cube is 3 square A. Similarly, see, A square is 3A. A cube is 3 square A. A power 4, tell me, ma'am, 3 cube A. Okay, we are getting it now. Let's go back. So A square is 3A. So we'll start with 3A. Then it will be 3 square A. Okay, and all the way up to 3 power 9A. Okay, if you take A common, it will be 3 plus 3 square and all the way up to 3 power 9. How many terms are there? 3 power 9. Correct? How many terms? So, ma'am, total 9 terms, so we can see. Okay, 9 terms. 3 power 1. Okay, 9 terms. GP of 9 terms. First term A, r power n minus 1 upon r minus 1. Can you see how beautifully this question has unfolded? Okay, so 3 power 9 minus 1 is matching with, can you see option B? JEE Main 2022. Pattern based multiplication. How many of you are understanding? Yes? All right. Clear? Pattern based question. Are you understanding? So whenever you see higher powers of A, all you have to, one more pattern based question, and you know what? This is my favorite question because this question was there in JEE Advanced in the beginning. Previous year question, maybe 2016. JEE Advanced 2016. Then JEE Main 2021 question. Then JEE Main 2025 again, and not even once, the same question they have asked in JEE Main 2025 twice. Twice they have asked this question. Okay, ready for it? Up for it? After every 1 hour, we are going to analyze. Like after every, not 1 hour, but approximately 1 hour, that till now what are important topics we have done. Okay, we'll just connect the dots every hour, that okay, this is what we have learned, this is what we'll keep in mind. Okay, yes everyone? Okay, all right, perfecto. A matrix is given, P matrix is given. Yes? Okay, this is the ninja matrix, ma'am. Ninja matrix. Ninja matrix spotted. Ninja matrix spotted, everyone. Okay. Anyway, A matrix, P matrix, and now B matrix is nothing but PAP transpose. C matrix is P transpose B power 10 P. Sum of diagonal elements of C. Basically, they are looking for C. Okay. So now one thing. What is C? C is having B power 10 and B also is given to you. So all I will be doing is I'll be just writing B power 10. So PAP transpose power 10 and this is just P. Now C, let's open this C. P transpose. This is PAPT. Oops, I forgot to teach you transpose. Kya? I forgot to teach you transpose. Okay. Anyway, just one thing. We'll study transpose, but right now, transpose. What is transpose of a matrix? Suppose A matrix. Let's talk about P only, na? P matrix. Can you see? Cos theta minus sin theta, cos theta. What will be P transpose, anybody? P transpose will be nothing but interchange of row and column. So this is your row 1 now. This will become your column number 1. This is your row number 2. This will become your column number 2. This is your P transpose. Okay. Just the basic definition of transpose you will need and you will be done. Okay, ma'am. Yes. PAP transpose, PAP transpose, PAP transpose. How many times I should be writing, ma'am? 10 times. 10 times. Okay. And eventually you have to write just P in the end. Okay. Ma'am, I can see that P and P transpose are getting multiplied. P transpose into P, P transpose into P, P transpose, and eventually in the end also PAP transpose. So P transpose into P. So I need P transpose into P. So just multiply P transpose and P together. So tell me, P transpose into P. Understand, in such situations, P transpose into P is going to come either identity matrix or 2 identity, 3 identity, like that. Very basic thing, like very simple thing. So ma'am, P transpose into P, so row 1, column 1. So cos square plus sin square, ma'am, it is coming 1. This into this, so cos sin negative, cos sin positive, 0. Now this, can you see? Minus sign, so again 0, and this multiply this, sin square plus cos square 1. Can you see? P transpose into P is coming out as identity. So this is identity, this is also identity. So only can you see A in between. So C is equals to IA. Okay, 10 times. Eventually I. 10 times. Okay, so I, if I multiply IA, this will become what? A, A, A. So this is A, how many times? 10 times. Basically, C is nothing but A power 10. This is what we have got. Pattern based multiplication. Now I think I don't need P matrix. No ma'am. I don't need B matrix. No ma'am. I don't even need C matrix also. C is A power 10. They are looking for sum of diagonal elements of C. That means they are looking for sum of diagonal elements of A power 10. Here A is 1 by root 2 and minus 2, 0, 1. Now understand. A power 2. First of all, A square, let's calculate. And you know what? We are looking for only diagonal. Be very smart. Do not calculate every number. Only diagonal. Okay. So first diagonal will be 1 by root 2. That's it. So 1 by root 2 square. And the second diagonal will be 0 and 1. Okay. Okay. A square is this. A power 10. You know what? Will be what? 1 by root 2 power 10. And this is 1. Now sum of diagonal elements of this is what? Sum of, basically they are talking about trace of A power 10. Correct? That's what we are looking for. So 1 by root 2 power 10 plus 1, which is 1 by 32 plus 1, which is 33 by 32. M by N is 33 by 32. M by N 33, 32, 65, and we are done. Okay? Yes? See this question? I absolutely love this question. Okay? All right. Clear everyone? Yes. Pattern based multiplication. How many of you are getting it? Now, transpose of a matrix. The next topic over here. Transpose of a matrix. Correct? Transpose, so I have told you now that rows and columns becomes exchanged. Okay. So A matrix, suppose 2, 3, 4, 5, 7, 9, 1, 7, 0. So A transpose, can anybody tell me what would it be? So 2, 3, 4 will become 2, 3, 4, 5, 7, 9, 1, 7, 0. Okay. So this is transpose. Now understand, there are some properties of transpose. Also, transpose can also be represented by a dash. A power t, or A dash will also work. See. Basically, first property says if you take transpose of A and one more time if you are going to take transpose, you will get back to A, back to original matrix you are going to get. Okay. Now, the next property is that suppose you have K times A and you have to take transpose. You know what? This K is very innocent. K has nothing to do, absolutely nothing to do with transpose. It will come out as it is and A will still face the consequences of transpose. Okay. Now, suppose A plus B transpose is given to you. Very easy. You just have to do A transpose plus B transpose. So here A, this is expandable. This property is expandable for n terms also. So over here, now this is very important property over here. Important for JEE Main 2026, which is reversal property. AB whole transpose is equals to B transpose A transpose. And one more thing, if ABC transpose is there, then C transpose B transpose A transpose, reversal law is applicable. Everything is going to get reversed. This is so important for JEE Main and JEE Advanced as well. Very important property. Do not forget. Okay. Yes, everyone. Clear? Now, yes, trace of A matrix is equals to trace of A transpose. That so I can show it to you also. Tell me, what is the sum of diagonal elements of this matrix, A matrix? Ma'am, 2 plus 7 plus 0, 9. And here also same. What does that mean? One thing to notice. One important thing to notice, observation skills, my dear students. Is your brain braining? A matrix and A transpose are having same diagonal. Think about it. Think about it. Anyway, we are going to solve one question based on that, which is JEE Main 2021 question. Ready for it? See, I told you I have so many questions for you already. So many questions for you. You can count in these 3 hours mathematics. Solving mathematics question and solving chemistry questions. There is a difference. The time is different. Okay. So over here, let's see. For the matrix A transpose is I2. Okay. So A transpose. Everybody, if you can multiply. Ma'am, 1 minus alpha, alpha, beta. Okay. 1 minus alpha, alpha, beta. Understood? This is A transpose, because here this is original A matrix and this is A transpose matrix. I have interchanged. Okay. Now A transpose, multiply. So ma'am, 1 plus alpha square. Okay. And then alpha minus alpha beta. What about this? Alpha minus alpha beta. Okay. And what about this? Alpha square plus beta square. Okay. So over here, now this is your identity matrix. That means this will be equals to this. Okay. So 1 plus alpha square is 1. That means alpha square is 0. This will give you alpha equal to 0. Alpha is coming out as 0. Okay, clear. Now what about this? If alpha is 0, that clearly means that this and this both are becoming anyway 0 only. So this will not give me anything. What about this? Alpha square plus beta square is going to be 1. Alpha is 0, so beta square is 1. What does that mean? That beta is plus minus 1. Anyway, I don't need anything. Now this has become a very easy question, don't you think? Don't you think this has become a very easy question? Alpha is 0 and beta power 4 is 1 power 4. So option A, absolutely right. JEE Main 2021, what are you doing? JEE Main 2021, NTA has dropped some level because of COVID-19. What do you think about it? Anyway. Alright, now here comes our brand new topic. Important, very important for JEE Main and Advanced. Main plus Advanced. Main plus Advanced. Main plus Advanced. Okay. Yes. Are we ready for it? Give me a big thumbs up. Okay. So if A transpose and A matrix becomes equal, if you take a transpose and then also your A matrix and A transpose becomes equal, then it will be called as a symmetric matrix. And if now you take A transpose and it is equal to minus A matrix, then it will be called as skew symmetric matrix. Okay. But let's understand the whole situation in detail now. Okay. Alright. So now again, A transpose is equals to A matrix. Correct? Okay. So in that case, there is, what is so special? Think about it, ma'am. You are taking transpose and then also the matrix is not changing. It is becoming same. There would have been some special thing about that matrix. Right? There would have been some special things about that. What is so special about that matrix? So special thing is that the diagonal elements, there is no condition on it, because you know that whether it is transpose or the original matrix, diagonal elements are same. But the non-diagonal elements become different when we take transpose. So basically, the conjugate elements are equal. Aij and Aji will be equal. Okay. So suppose there is a matrix A which is having 2, 0 and 5. as a diagonal elements. Okay. So diagonal elements, no condition. Absolutely no. It can be 0, it can be non-zero, it could be anything. But there is some condition on non-diagonal elements. This is A12 and this is A21. These two are called as conjugate element and these two elements should be equal. So if this is 1, this also should be 1. Now what about this? Ma'am, this is A13 and this is A31. So these two elements are also equal. And if at all, this is A23, A32. These two are also same. Now if you take the transpose, tell me honestly, take the transpose, ma'am, 213, so 213, 213, 213, 10, 10 minus 2, yes ma'am, now 3 minus 2, 5. Can you see A and A in transpose are equal? What does that mean? A matrix who is symmetric matrix, it will have its conjugate elements equal. That's it. That's the identification. Okay, ma'am. But ma'am, now what is skew symmetric matrix? If you take transpose, it will become minus A matrix. Suppose this is your A matrix. Now take transpose. What will happen? So ma'am, 0 to 4, 0 to 4. Minus 2, 0, minus 3. Minus 4, 3, 0. Can you see? Thank you, Gautam Kishore. Thank you so much. Chalo, A transpose. Can you see? Are you serious? Can you see? Don't you think that here 2 minus 2, 4 minus 4, minus 2, 2. Can you see the numbers are exactly negative of this, right? So that means A transpose is equals to minus A. Again, now ma'am, what is so special about skew symmetric matrix? So in skew symmetric matrix, diagonal elements are equal. Diagonal elements are equal and non-diagonal elements, now the conjugate elements are equal but opposite in sign. Can you see? Minus 2 and 2, minus 4 and 4, 3 and minus 3. So these two are same but opposite in sign. That is so special about skew symmetric matrix. Now, okay. Now let's do one question based on symmetric and skew symmetric matrix so that you understand better how to handle such questions, correct? Very important topic. Although if I talk about JEE in 2025, hardly few questions were there from this topic. But if I talk about 24, 23, 22, 21, you will see a lot of questions. So yes, there is some discrepancy. So if you will ask me, ma'am, is this topic important? If I talk about 5 years, yes, it is important. But is it very, very important, topmost important? Then topmost important topics are like the priority 1 topics are different. This is priority number 2, but still the important one. Okay. Yes. So I think one question. Yes. Let's solve. Okay. A and B are only two symmetric and skew symmetric matrix. Okay. A is symmetric. That means what? A transpose is A. B is skew symmetric. That means B transpose is minus B as per this question. Which of the following is not true? Not. Focus on not. Okay. So A power 4 minus B power 4. Is it a symmetric or not? So let's take this as, let's say, X matrix. A power 4 minus B power 4. We need to check whether it is symmetric or not. So what we will do is, we need to prove or we need to check X transpose is equals to X or not. Verify this. So let's take transpose now. So this is A power 4 minus B power 4 transpose. Remember the properties of transpose. Okay. Now I told you that whenever there is sum or subtraction, the transpose can directly will be applicable over here like that. And one more thing, the power and transpose are interchangeable. Okay. What you can do, what not you can do, I am going to tell you. Now A transpose, can anybody tell me? Ma'am, you can write A. So A power 4. B transpose is minus B. So minus B power 4, anyway this minus sign will get cancelled out. So this is a power 4 minus b power 4, which is nothing but x, original x. So you started with x power t, which is equals to x. Is this a symmetric matrix? Yes. So this is a true statement. We are looking for not true statement. Okay. AB minus BA is a symmetric matrix. Let's take Y. Y is AB minus BA. Now you need to check whether Y transpose. Take transpose. AB minus BA transpose. Now you know this is AB transpose minus BA transpose. One more thing. Now reversal property will come into the picture. This is B transpose A transpose minus A transpose B transpose. And now this is B transpose. B transpose is minus B. A transpose is A. Minus A transpose is A, and this is minus B. So minus BA plus AB, which is AB minus BA. Okay, AB minus BA is Y only. So Y transpose and Y are equal. So this is also true. Oh, I am looking for not true. So much effort. Okay, anyway, let's be hopeful for C. See, sometimes it happens with me also, with everyone. That not true we are looking. See, we can't do anything about it. This is all about checking options. Okay. Yes, if you have done a lot of practice, that you can sense that which one is symmetric, which one is not symmetric. Now suppose this is C matrix. C transpose is what? P power 5 directly. Let's do the transpose thing. So transpose minus A power 5 transpose and power is interchangeable. Okay. So B transpose power 5 minus A transpose power 5. B transpose is minus B. So minus B power 5 minus A. A transpose is A only. Correct. So this is minus B power 5 minus A power 5, which is not equals to C matrix. Okay. And which is not equal to minus C as well. C transpose is not matching with C nor with minus C. Hence, C is not skew symmetric matrix, and I don't have an energy of checking D. Now you will check for me. Yes? Okay. Clear, everyone? Are you with me? Shall we move on to the next thing over here? Okay. Ready for some ninja style? 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 Okay. So basically every 2 cross 2 matrix is associated with A square minus is associated with degree 2 polynomial equation, right? Degree 2 polynomial equation. Okay, a 2 cross 2 matrix is directly closely. Now please understand, this is very secret. This is quite hidden thing which I am telling you. Okay, so understand this topic. If you go and check, this topic has a different way of teaching, and in fact if you go and Google also, Google characteristic polynomial and characteristic equation. First of all, so many theories, so many things, so much of written work will be there. You go and see the lecture also, it will be such a big thing. Okay, I am telling you the core and the crux of that topic, which is directly helpful in question solving. Let me be very honest and straightforward over here. Okay, and in such a way that it is easily understandable for you also. Okay, A matrix, which is a 2 cross 2 matrix, directly associated with degree 2 polynomial, And now if it is 3 cross 3, it will be associated with degree 3 polynomial. Okay, it will look like a cube plus 3a minus 7a plus 4I is equals to 0, and it will be like a square minus 2a plus 4I is equals to 0, like this. Okay, sample, I'm just trying to tell you the sample thing over here, that a sample equation of a random 2 cross 2 matrix will look like this and 3 cross 3 will look like this. Now what is the ninja style over here? Okay, so now what if you know the matrix now? If you know the matrix, you can write that degree 2 equation. If you know the matrix, you can write that degree 2 equation with the ninja technique. Otherwise, to write that degree 2 equation, there is a long 2-page process which we are going to cut short and directly going to give you the shortcut to directly write the equation. Okay, so this will be a square minus trace of a into a plus determinant a into I is equals to 0. Okay, correct? A square minus trace of A. A matrix, if you will know, A plus D. So this is A plus D. And determinant A, you can calculate. Correct? Give me a big thumbs up. Now, any question in the history of JEE, be it 2021, be it 2030, 2040, 2050, in any year, this video will stay here, right? Even if I don't stay on this earth, this video will stay over here on this channel. JEE Main will get conducted even in 2025, hopefully. Okay, if the name will get changed, but this mathematics will stay. JEE Main engineering entrance exam cannot get free of mathematics and it cannot get free of matrices. Very important chapter. Now, any question involving matrix giving you a equation is directly associated with this. Just focus on this. Okay? Alright. Let me tell you why I'm telling you all this thing. Okay? Suppose this. This is a question, by the way, and this is a JEE Main 2025 PYQ. Okay? They will not tell that hello. They will not tell that Rajkumar, hello, listen. Ninja style characteristic equation, can you apply? You have to sense. How will you sense? You will be like 2 cross 2 matrix, okay, and an equation is given. 2 cross 2 matrix, equation. 2 cross 2 matrix, this is an equation in A, right? But ma'am, you to told ma'am degree 2 equation will be there. This is the not degree 2. So let me tell you. What is this? This is A inverse alpha A plus beta I, correct? So what you can do is, you can just multiply A. So it will be I is equals to alpha A square plus beta A. So it will become alpha A square plus beta A minus I is equals to 0. Okay? Yes? That means indirectly they have given you a 2 cross 2 matrix and a hidden degree 2 polynomial equation is given to you. Okay? So let's keep this aside. Let's push this on the left hand side and now focus on this. This is given. Symmetric matrix. So let us assume that A matrix. How to assume a symmetric matrix? Ninja Ma'am has told that diagonal elements could be anything, but there is a condition of non-diagonal elements. Non-diagonal elements should be equal, basically the conjugate ones. So CC. This is symmetric. This is how you assume a symmetric matrix. The conjugate elements has to be same. Okay. This is your A matrix. Now if you multiply this A matrix with 1, 1. Sorry, this is 7. Okay. This is 3, 7. Misprint, this is 7, okay. Now just solve it. So this is A plus 7C. A plus 7C is equals to 3. And this is C plus 7B is equals to 7. Okay. And the determinant value also is 1, correct? So AB minus C square is 1. 3 equations, everyone. 3 equations and 3 unknown. Can we get the value of A, B and C? Can anybody help me in getting the value of A, B and C, everyone? Okay, let's put now. Oops, sorry. This is correct, huh? This is correct. This is 1 only, right? This is 1. I actually wrote incorrect. This is 1. Yes, now it's correct. Okay. So now I think A plus C is equals to 3. Correct? A plus C is 3 and C plus B is 7. Now let's plug in the values over here. So it will be A. A is what? Tell me. A is C minus 3. So C minus 3. And B is 7 minus C. Okay. And this is 3 A is 3 minus C. Correct. This is 3. Okay. 3 minus C and 7 minus C square is equals to 1. Let's solve this. Okay. So this is C square minus 10C plus 21 minus C square is equals to 1. C square cancel. So this is going to be 20 is equals to 10C. C is coming out as 2. The moment C is 2, so A will be 1 and B will be 5. So in that case, your A matrix is decoded, everyone. A matrix is decoded. Understood kya? Or there is some gitch pitch over here. Okay. Let me do it nicely for you. Okay. Alright. So one thing that determinant A is given as 1. Correct? So determinant A, tell me. So ma'am, determinant A is equals to AB minus C square is equals to 1. Now understand, AB minus C square is 1. AB. Can you tell me value of A, ma'am? 3 minus C. Value of B similarly 7 minus C is equals to 1 plus C square is equals to 1 plus C square. Correct? So this is C square minus 10C plus 21 is equals to C square plus 1. C square cancel. And this is 20 is equals to 10C. C is nothing but 2. C is 2. Everyone. C is 2. Correct? The moment your C is 2, A will be 1 and B will be 5. And hence your A matrix is decoded. Okay. So A matrix is decoded. Now tell me, can you write the characteristic equation with ninja style? Yes, ma'am. Ninja style says that A square minus trace. Trace is A plus B. A plus B is 6A. Plus determinant of A to already given now. So 1 into I is equals to 0. So A square minus 6A plus I. So A square minus 6A. A square minus 6A plus I is equals to 0. Now you have to compare. Ma'am, if I compare minus A plus A not matching, so multiply it with negative. Minus A square plus 6A minus I is equals to 0. Now tell me alpha coming out as minus 1 and beta 6. Alpha minus 1, beta 6, 5 is absolutely correct answer of this question. Yes, absolutely correct. This is a JEE Main PYQ. Yes, this is a JEE Main 2025 PYQ. Or is it a 2024 PYQ? I am not sure, but this is a JEE Main PYQ. 2024, sorry. 2024. 4. JEE Main 2024 PYQ. Yes, everyone. Getting it? Good question. Ninja style, but good question. Okay. Alright. Okay. Now some special type of matrix. Some special type of matrix. How many of you are up for some special type of matrix. Okay, so some special type of matrix, orthogonal matrix. In fact, you know what? We have seen one orthogonal matrix where A transpose into A or A into A transpose is identity matrix. Remember that ninja matrix is actually orthogonal. Cos minus sine, sine cos, that is orthogonal. Idempotent is when A square becomes A. Involutory is when A square is I. Nilpotent matrix when the very first index K, where A power K becomes null matrix. Periodic matrix means that we have also done that. Remember, A square was coming A cube was also A power 4 was. So ye to been there, done that. Been there, done that. In fact, been there, done that. Okay, in fact, these two to we have done. Okay, yes. So this is live, absolutely live. What made you think that this is not live? Okay, now one very important thing I would like to tell you. I don't know how many of you are ready for it, but I though want to tell you because this is important for JEE main, but more important for JEE advanced. Okay. Yes. Suppose you have a little observation: A B C D E F G H I. Okay, this is A matrix. And if I multiply A and A transpose, okay, A and A transpose, so it will be A, B, C, D, E, F, G, H, I. Now you will be like, ma'am, are you going to multiply this? No. I am only going to multiply and figure out the diagonal elements of A into A transpose and make sure that I will tell you the diagonal, what is so special about the diagonal elements. Multiply. See, first diagonal will come when you multiply row 1, column 1, A square, B square plus C square. Interesting. Second diagonal element will be row 2 and column 2, D square plus E square plus F square. Row 3, column 3, G square plus H square plus I square. What does that mean? What does that mean? That trace of A into A transpose is nothing but A square plus B square plus C square plus D square plus E square plus F square plus G square plus H square plus I square is nothing but sum of square of all elements of A. Yes or no? Don't you think that this particular thing is mind-blowing? Mind-blowing information. Now, let me tell you. One question was asked from JEE Advanced based on this concept. And in 2025 now, okay, in 2025 or I don't know, but in some JEE main previous year question, the same concept was used and exactly what we are going to do this. Can you see? Can you see? Okay, this is a JEE main PYQ. JEE main PYQ. And this category is what? PNC plus matrices, very popular category among NTA. Okay. Yes. Very popular category. Permutation and combination combined, clubbed with matrices. It's a very popular category of JEE main since past couple of years. Okay. Yes. Let's see. The total number of 3 cross 3 matrices A having entries from the set 0, 1, 2, 3 such that sum of all diagonal entries of A into A transpose is 9. So now we don't have to do the hard work, the long work. We know that sum of diagonal entries, so basically sum of all diagonals should be 9. That means what they are saying is A square plus B square plus C square plus d square plus e square plus f square plus g square plus h square plus I square is equals to 9. If we know that concept, then the question will be very easy for us. Okay? Then the question will become very easy for us. If just in case we know that. Okay? Now, matrices A. What is matrix A? So now matrix A so is this now A, B, C, D, E, F, G, H, I. Correct? Everyone? Are you getting my point? Yes? Now tell me, case number 1. You have to think a lot now. Case number 1. What will happen, ma'am, if all the elements become 1? 1, 1, 1, 1, 1. How many elements? By the way, there are 9 elements. And if every element will become 1, all 1. Okay, so how many, in how many ways all can become 1? There is one case. So case 1, all elements, all equals 1. So one such case will be possible. Okay, everything is becoming 1. Now case number 2, think about it. So ma'am, case number 2 means, suppose if not 1, then let's go with 2. Okay, so ma'am, you have 2 and you have one more 2. Okay, let's make 1, 2. So 4 will be there. Now rest 5, 1, 1, 1, 1, 1. Tell me, 2 square will be 4. Plus 1 square 5 plus 1 square 6, 7, 8, 9. Ma'am, yes. So we need single 2 and 5 times 1. Okay, and the remaining 3 elements will become 0. This will give me, if you square and add all the 9 elements, you will get easily, 9, correct? So now you have to shuffle. There are 9 elements, there are 9 places. You have to shuffle these 9 elements. Okay, so it will be 9 factorial upon 5 factorial, 3 factorial. So answer will be what? 9 into 8, 7, 6, 5. 7, 6, 5 factorial gone upon 3 into 2 into 1. So 6 and this is gone. 9 7s are 63 into 8 everyone. 8 3s are 24. 8 6 are 48. 504. This is 504. Okay. Case number 3. Everyone. Think about it. Now if I keep 2 and 2. Okay, let's increase the number of 2. So ma'am, it will be 2 square 4, 2 square 4. 8 is already there. Now there is only gap of 1. So now this is becoming 9. Rest everything is 0. So 1, 2, 3. So 6, 0 will be there. Okay. So now 9 numbers, 9 places. So 9 factorial upon same है तो 2 factorial and same 6, 6 factorial. 9, 7, 6 upon 2. So 9 into 7 into 6 by 2. So this is 3. 9 7s are 63. 63 into 3. 3 3s are 9. 6 3s are 18. 189 such cases. Now, is there any case number 4 by the way? Ma'am, case number 4 would be if you keep 1, 3 and rest everything will be 0. So 1, 3. So basically, you just need to fix the position of 3. Case number 1 when A can be 3 or B can be 3. So there are 9 cases clearly. So 9 such cases are possible. So final answer will be what? Tell me. 1, okay, 1 plus 9 plus 504 plus 189, correct? Okay, and if you're going to solve it, 766 will be the answer. Let me check. 10, okay. Have I done any mistake? 252, you're saying. Have I done any mistake? 5 and 4, okay. This is 4, correct. 5 and 4. 1, 2, 3, 4, 5. 5 and 3, no? 3 is correct. What about here? So this is 1, 2, 3, 4, 5, 6. 6 and 2. Yes. So 9, 7, 8 upon 2. 36. Oops, I missed one thing, right? Sorry. This is incorrect. This is 9. It should be 9 into 8 into 7 upon 2. Yes. So 36 into 7. 36 into 7. 36 into 7. 7 6 are 42. 4 carry. 7 3 are 21. 21 plus 4. 25. 252. Yes, this is 252. So this is not 189, 252. And if you solve it, now it will become 766 as the answer. Yes, correct. Thank you. All right. So this is how this question is going to unfold. Are we ready for the next thing? Are we ready for the next thing? Ma'am, looking sleepy. No, I am not sleepy. I am very active. I am very happy. I am very energetic, very motivated. You are looking sleepy and you are transferring that sleepiness, lazy, and lethargic over here. Okay? Don't do that. Okay. All right. Perfect. Now let's see this next question. Square matrix A said to be singular, non-singular. Acha, what is the singular matrix? Singular matrix whose determinant is 0. Non-singular means determinant not equal to 0. Now JEE Main 2025 again another question, same category, PNC plus matrices. I know this is not a very easy category. Sometimes it is easy, sometimes it is trouble. Okay, but don't worry, Ninja Ma'am is here and yes. Okay. The number of singular matrix of order 2. First of all, let's assume a matrix. A, B, C, D. Correct? Now singular, that means determinant A should be 0. So AD is equals to AD minus BC is equals to 0. That means AD and BC are equal. Okay, now this set is given 2, 3, 6, 9. We need to, now this is a manual question. We have to think a lot that when exactly on what values AD and BC are becoming equal. Okay, ready for it? You have to apply thoughtful brain. Now, elements should be from 2, 3, 6, 9. Now, just tell me one thing. Don't you think that one such case which is striking our brain is, what if every element becomes 2, 2, 2, 2? It is becoming very easy. Because if A and D are 2, B and C also 2. So this is 4 is equals to 4. And yes, ma'am, done, it becomes singular. Okay, so this is where my case number 1 comes. That where all elements are same. All elements are same. Okay. So if I pick 2, so let's pick one number. Let's pick 4C1. 4C1. Or rather than that, if you don't want to apply permutation and combination, clearly there will be 4 cases. Okay. First case, when A, B, C, D all are 2. Second case, A, B, C, D all are 3. Third case, A, B, C, D all are 6. Or all are 9. So 4 such cases are possible. Case number 2 now. Case number 2 says that exactly 2 numbers will pick. Okay, so here exactly one number is used. Now exactly 2 numbers. Now if I pick exactly 2 numbers, first of all let's pick those 2 numbers 4C2. So suppose now apply brain. Suppose I have picked 2 and 6. Okay, 2 and 6. And I have to make this AD is equals to BC thing. Okay, so if A is equals to C, AD and BC. If A is 2, correct, 2 numbers. So D is 6, correct. If A is 2, D is 6, then B and C will be 2, 6 and 6, 2. Correct. Now if A is 6 and D is 2, again 2, 6, 6, 2. Basically 4 such cases are possible in that case. So 4C2 into 4. 4C2 is what? 4 into 3 by 2. 12 by 2. This is 6 4s are 24. 6 into 4, so 24. Correct? Now case number 3. When you take 3 numbers, exactly 3 numbers, but if you take 3 numbers, think about it. Suppose I take 2, 3 and 6. Now what can I do? If I just keep A as 2, this as 3, I can't be keeping this as 6 and 2. No, it cannot happen. 3 numbers, I don't think 3 numbers cannot be used. This is not possible. Case 3. Case number 4, all 4 numbers we have to use. All 4 used. Now, if all 4 used, then we have to go by multiplication, that which 2 numbers are giving same multiplication as other 2. Is it happening, by the way? So, ma'am, if I multiply 9 2s are 18 and 6 3s are 18. Yes, ma'am, it is happening. Yes, so again, A and D. Okay, B and C. So, if A is 2, D should be 9. Correct? Now, B and C should be 6, 3, 6 and 6, 3. Interchange. Okay. Now, this time, this is 9 and this is 2 and this is 3, 6, 6, 3. Okay. Correct. Now, same thing can be done. How many cases, by the way? Now, same thing can be done. Now, if A and D could be 3, 6 and 6, 6. So, I think this is 4 cases. Okay. Now, 4 more cases will be there in which, you know what, A will be 3 and B will be 6. So, again 2 cases and 6, 3 again 2 cases. So, total 4 cases. 4 plus 4. Case 4 is having 8 cases, my dear students. Okay. 8 cases. Case 4, 8 cases. So, now add 8, then we have 24. So, and then 4. So, 8 plus 4 plus 24 should be your answer. So, that is 36. Is it 36? 24 plus 12. Yes, 36. 36 such matrix are possible. Okay. Yes. Alrighty. Perfect. Okay. Alright. Now, let's talk about determinants. Okay. Let's talk about determinants. I told you now, the class will go up to C. I think we'll take, it is 1.5 hours, like 12:30, before 12:30 we'll finish. Okay. So, if you are facing dullness, sleepiness, just refresh yourself, wash your face, come back, finish this. Okay. And if you feel that, oh, it is not happening, not at all happening, okay, then also just wash your face and come back and sit. Finish the topic. Okay, your brain will start braining. You just need a small break. Okay. See, I have to tell you something. There is a famous Einstein's walk. You know what? Famous Einstein's walk, which is so famous in Princeton University. Okay. So when Einstein was doing his research work in Princeton University, and you know what he used to do? He used to solve a problem and he was not getting it. He was not satisfied by the outcome of it. And he started realizing, I am sitting and I am thinking in one single direction. Okay, I am thinking in one single direction. I think this problem needs altogether a different approach. And you know what? Einstein cannot ask doubts from Ninja Ma'am. Okay, Einstein is not having any mentor. He is the GOAT. He is there to tell everyone that what is happening, what is not happening. So everything has to come from his brain. He was creating everything from his brain, thinking from his brain. So what he used to do is, he used to go out and have a walk in Princeton University, and everybody used to see him. Nobody used to talk to him because everybody was aware that he was having his time, his walk, so that now he can go back, and then he used to come back after his famous walk, and his mind was completely different. The approach was completely different. Same question, same problem he used to solve, but now the approach has a new, fresh perspective what he needed. Okay, so sometimes it happens that our brain doesn't brain. It happens with Einstein also. Brain is not braining. Just go and change your thing. Go and take that Einstein walk in your neighborhood. Come back. Okay, go and wash your face. Come back. Sit with a fresh, different perspective. You will realize that, oh, things are different now. Okay, yes. Okay, shall we start on this note? We are going to start determinants now. Fresh perspective, fresh. Okay, and you know what, in this 2 months of your journey, approximately 2 months are there in first attempt, a lot of times it is going to definitely happen that you feel saturated. School, your boards will be there, school will be there, JEE pressure will be there, three subjects, so many chapters. So many times you will feel that, okay, I am saturated, ma'am, my sleep is not proper, my brain is not working, what to do? Don't do anything, just dump everything and just take a break. Take a break, come back, start fresh. And you'll be like, things are easy, not very difficult. I was only one who was taking the stress. Okay, yes, okay. So these are the hacks to keep human brain stress free. Okay, and especially I am talking about JEE aspirant. How to keep a JEE aspirant brain stress free? Okay, the answer lies in Einstein's walk in Princeton University. Okay, chalo. So over here, determinants. Okay, so unlike matrices, determinants are always square. Okay, so matrices 3 cross 2, ma'am, yes, can happen. 3 cross 2 matrix, yes, ma'am. But determinants are always square. Okay, matrices is just an arrangement. Matrices doesn't give a value. Unless you take determinant of it, then it will give a value. Okay, so it is always a square, and the representation is similar but different from matrices. So suppose delta, and this is going to be 2, 3, 4, 7. This is determinant. Okay, sorry. What is this? What is this? Tell me, this is half matrix, half determinant. LGBTQ. This is LGBTQ. Okay, sorry. This is now perfect determinant. Okay, how to solve 2 cross 2 determinant? Very easy. 7 2s are 14, 4 3s are 12. So this is 2. Not a very difficult thing. Okay, yes, solving 2 cross 2 matrix. Alright, determinant value now 1 cross 1 determinant also exists. Suppose delta is this. This is not modulus. This is determinant 1 cross 1. So this is just 3. The value is only determinant. 2 cross 2, I have just told you. Okay, right? So this is how determinant is. Now to actually understand a determinant, 2 terminologies are needed. To understand matrix, you understood now what is row, what is column, what is order, okay, square matrix, etc, etc. Like that only, determinants also have some terminologies. Number 1, you have to understand the minor. Number 2, you have to understand the cofactor. Are we ready for it? It will take 2 minutes. And then quickly we'll straightforward go to the question part. Okay? Yes? Okay. Yes. So if right now, can you see, let delta be a determinant. This is my determinant. This is my determinant. Okay? Now this determinant is A, B, C, D, we know. Okay? Minor. So every element is associated with its minor. Okay? So what is minor of element A? Minor of element A, that is M11, will come when we hide the column associated with A and row associated with A. So I think the only left out element is D. So M11 is D. Similarly, okay, M12. This is your M12. Now M12, you hide the row and hide the column. Can you see C? So M12 is C. Similarly, M21 and M22. So this is how minor is right here. Now what about cofactor? So there is a formula, directly link cofactor and minor together. Cij is equals to minus 1 I plus j mij. Basically, if you are looking for C11, it will be positive M11. Why? Because 1 plus 1 is an even number, so it will give positive C11 M11 equal D. C12, 1 plus 2, 3, odd number, negative. So C12 is minus M12, so that's why minus. C21 again negative and C22 again positive because this. Okay, this is the formula. When I plus j is even, then cofactor minor same. I plus j becomes odd, then it will give a negative sign. Okay, yes. Chalo, JEE Main 2019. I'm not sure about it. I don't know. There is some what? You were writing something. Some big paragraph. Okay. Okay. Anyway, I'm not sure whether it is a JEE Main PYQ or not, but yes. M31 in the determinant is 1. M31. So M31. 1 1 1 2 1 3 2 1 2 2 2 3 3 1. So you are looking for minor of 3 1. How will you look? So first of all, this 1, hide the row, hide the column, hide the row, hide the column, and whatever is left out, just write in the form of a determinant minus sec alpha and tan alpha. This is your M31, and as per the question it is given as 1. Solve. Tan alpha, this minus sec square alpha plus sec square alpha, okay, is given as 1. Okay, now we need to figure out the value of alpha. So tan alpha is equals to 1 minus sec square alpha. Okay. So 1 minus, see, 1 plus tan square alpha is equals to sec square alpha. Okay. So now 1 minus sec square alpha is minus tan square alpha. So this is going to be minus tan square alpha. So clearly tan alpha will be either 0 or minus 1. Okay. What they are asking is then the value of alpha would be what? So value of alpha, then the value of alpha could be 0 or alpha could be 3 pi by 4 as well. So two values we are getting 0, 3 pi by 4. Okay. 4 cross 4 usually in general you will not see in JEE Main. Yes, you will not see. Mostly you will not see. This is your determinant. Okay. Now are we ready to understand a couple of important properties of determinants? Tell me in the chat box, everyone. Are you ready to understand the couple of important properties of determinants, right? Quickly we'll do, okay? So property number 1, property, this is not a property basically, this shows that how can you expand a determinant, okay? So expansion of a determinant can be done either by any row or any column, okay? Suppose usually we do it by row wise, so row number 1. So what will we do? A11 will write minus A12. Now you'll be like, ma'am, why negative? Because you know what, minus A12, because 1 plus 2 negative, that connection, okay? You will realize what I'm trying to do is, and A13. This is expanding or finding value of a determinant along row 1. Along row 1. Okay, so now row 1. So A11. So A11. Now A11, if you are going to hide, then this is the matrix. Remember, minor. So this is A22, A33 minus A32, A23. I'll come here. See, A11 minus A12 plus A13. Okay, so now A11 is gone. So this multiply this here. Okay, minus A32, A23. Okay, now inside this bracket, again same technique we are going to apply. A12 is right here and this multiply this. A21, A21, A33. Okay, so A21, A33. This, okay. So A21, A32 minus A31, A22. Can you see? This is by first row and similarly this is by second row, correct? Okay. Now one more thing, in terms of minor also you can write, see, if you have to expand along row number 1, what will you do is A11, M11, that's what we were doing, minus A12, minor 12, plus A13, minor 13. And more importantly, this is very important. If at all, now understand this very, very nicely, because this is so important, I can't even tell you how much important is this. This is important for determinant, this is important for matrices. Understand what I've tried to say, okay? Suppose A11, you are expanding along row number 1. So A11 will get multiplied with its cofactor C11. It can happen because M11 and C11 are equal. So basically A11 getting multiplied with C11, A12 getting multiplied with C12. You know M12 is what? Minus C12. So that's why minus minus plus. Now A13 multiplied with C13 and this will give you delta. Okay, this will give you delta. Okay, correct? So basically this thing, very important, this thing is saying that cofactor property, that if you pick any row and multiply the same row cofactor with the elements of that row, you will get the value of determinant. Sum of product of a row and corresponding cofactor will give you value of determinant. It is applicable for any row and any column. Okay. Now I know some of you might be thinking, ma'am, brain is not braining. Maybe we are not getting this property. So for all of you, I have designed one question so that you understand this property better. Okay. Just one more thing. Now you might ask, ma'am, if you are saying that if I multiply, if I pick any row, and if I multiply same cofactor, corresponding cofactor with its element, you are going to get C. If I am picking row number 1, so A11, A12, A13. Now, if I am multiplying each and every element with its cofactor, C11 is a cofactor of A11, C12 cofactor of A12, C13 cofactor of A13. If you're going to do that, you're going to get the value of determinant. Now, you must ask this, ma'am, okay, if it's getting multiplied with its corresponding cofactor, we are going to get value of determinant. But if I multiply A11, A12, A13 with the second row cofactors, C21, C22, C23, you will get a 0. You will get a 0. Okay, you will get a 0. Let's do this question, you will understand it better. Okay, this is your determinant, correct? Now I can clearly see that option A is having x minus y and z. Okay, x minus y and z. X they are multiplying with m21. This is 21 only. Y they are multiplying with m22 and z with m23, and you're going to get delta, which is true. Yes, option A is true. Correct? Okay, ma'am. Now A, B, C. This is your A, this is your B, this is your C. Correct? A is getting multiplied with C11. Remember, A is getting multiplied with cofactor of first element. That means B getting multiplied with different cofactors. C getting multiplied with different. So it will give 0. Yes, ma'am. This is absolutely correct. Okay. Now, A getting multiplied with C21. A getting multiplied with C21. C21 means second row. So third element is getting multiplied with second row. So it should give you what? 0. But it is not giving you 0. So C option is wrong over here. Okay. Now what about P, Q and R? So PM11 minus first row and minor of first row will give you determinant. So I think this is true. This is wrong. Yes, everybody getting it kya? Getting this property? How many of you are getting this property, everyone? If you are getting this property, then we can do one question. But I don't know how many of you are ready for this question, by the way. Ready for this question? Yes? Okay. So now, let A, this is a little bit misprint is here. This is A matrix, correct? Now, A matrix is given. First thing which is bothering me is why not just solve this now? A matrix, okay? So A matrix is nothing but, this is 128. 128 is what? 128 is, see, 2 power 6, 2 power 7, correct? So this is 2 power 7 only. Log, so 7 log 2 to the base 5. What is this? This is 1 by 2 log 5 to the base 2, correct? 4 is 2 square, it will come out, okay? Now what about this? This is 3 log 2 to the base 5 and this is actually log 5 to the base 2. This is your thing. Determinant A, if I calculate, what will that be? So if you multiply these two, see, log 2 to the base, understand, log 2 to the base 5 and log 5 to the base 2 will be 1. Right? You know the logarithm property, I hope you know. So if you multiply this, you're going to get 7 minus 3 by 2. 11 by 2 is determinant A. If you know the properties of log, then this determinant A will be sorted for you. But you must be wondering that, ma'am, why are you even calculating determinant A? Hold on. Maybe later on you might feel that, oh, I need a determinant A value. Now let's see what is going on over here. What is going on over here? What's going on? Aij is the cofactor of Aij. Okay. Aij, capital Aij is cofactor. Acha, so they have changed the notation basically, है ना? We used to denote cofactor by C, but they are saying that cofactor now is this. Okay. So Cij, okay, Cij is equals to sigma k is equals to 1 to 2 Aik and Ajk. Okay, all right. And this is your C matrix. Oh, C matrix. C is a matrix which looks like it is a 2 cross 2 matrix. So I need C matrix is 2 cross 2. So it will be what? It will be 1 1, 1 2, 2 1. Okay, basically this is C, C11, C12, C21, C22. I need these 4 elements, right? I need these 4 elements. C11. So for C11, I and J should be 1. Let's find out C11. Ma'am, C11 will be, so you have to put I and J both 1, sigma A1K and A1K. K is equals to 1 to 2. Let's open now. Put K is equals to 1. So A11, capital A11 plus. Put K is equals to 2. So A12, A12. Can you see what is this? A11 getting multiplied with its cofactor, A12 getting multiplied with its cofactor, 2 cross 2 matrix. So this is nothing but determinant A only. So C11 is nothing but determinant A only. Okay, 11 by 2. Determinant A value 11 by 2. Okay, alright. Now IJ1. Now what do you want from here? Ma'am, I want C12. So C12 means I1, J2. C12. Okay, slightly tricky, I agree. Slightly tricky. Okay, but stay there. You will understand it. Okay, so C12. I is, so this is sigma A1K and A2K. K is equals to 1 and 2. Now expand. So A11, A21 plus, can you see now? K is now 2. So A12, A22. Can you see A11 getting multiplied with cofactor of row number 2 and A12 getting multiplied with cofactor of row number 2. So this will give you 0. Remember two properties. If element getting multiplied with its cofactor, okay, when I am in my home, I will get determinant A. But when I am in others' home, I will get a 0. So this is when I am in my home. right? So I'll getting determinant A, other home 0. So this is 0. And similarly, if you find C21, you will get 0, and C22, you will get 11 by 2. So this is your C matrix, correct? And you know what? C, now they are talking about determinant C, that is going to be 11 by 2 whole square. Okay, so that is 121 by 4 if you have to multiply it with 8. Okay, so just multiply it with 8. 121 into 2. So 121 into 2 is 242. I would recommend to you all to repeat this exercise over here. Okay? Yes, everyone? Understanding it? Getting it? Okay? Alrighty. Clear? Yes. Next question on your screen is all about finding determinant. Okay, let's find the determinant. Okay, so this is this is given minimum value of determinant A upon B. So for that we need to calculate determinant A. Everybody, you know how to calculate determinant value? Everybody, huh? Do not get demotivated by just one question. One difficult question if I take, I see 50% of the audience run away. Don't do that. Come back. Determinant A, okay? Now solve it. 2 times this 2b square plus 2 minus b square. Minus b is right here. 2b minus b. Okay, 2b minus b. Plus 1 is right here. And this is b square minus b square minus 1. Correct or not? Yes, this is your determinant. Now this is 2. This is b square plus 2. Correct. Minus this is b into b square, and b square cancel, minus 1, so minus 1. So now this is 2b square minus b square. B square 4, 2 to the 4 minus 1, 3, minus 3. Whole up, this is determinant A. Now upon b. So whole upon you have to divide by b. Every time you have to divide by b. Every time you have to divide by b. By the way, this is plus. So this is what? Determinant A by b is nothing but b plus 3 by b. B plus 3 by b. B is given as 0. B is given as 0. Sequence and series, my dear student. Okay. AM greater than or equals to GM. So B plus 3 by B by 2 is greater than or equals to square root of B into 3 by B. B cancel root 3. So B plus 3 by B greater than or equals to 2 root 3. So this expression will be greater than or equals to 2 root 3. So minimum value is what? 2 root 3 is the minimum value, everyone? Yes? Okay. Alright. Ramya Mahesh is asking, ma'am, I have not started maths, physics and chemistry. I mean, what do you mean by not starting anything? Like, have you just taken admission in class 12th right now, right here? Ramya, what happened? Huh? Please clarify, because this statement only looks very scary that 2 months later your exam is there and you are saying, I have not even started physics, chemistry and mathematics. Okay. Thank you so much, Yogesh. Alright, one more question. Are we ready for it? Are we up for it? How many of you are up for it? Easy question. Come on, now I am giving you easy ones. Okay. In a triangle ABC, if triangle ABC, now if this is becoming 0 and this is what you have to figure out. Okay, let's open this. Okay. How to open this again? 1. Okay. C square minus AB plus, sorry, minus A. Now C minus A plus B. This is B minus C is equals to 0. So this is going to be A square plus B square plus C square minus AB minus BC minus CA is equals to 0. 9th graders are going to tell you that this statement has a condition, which is A is equals to B is equals to C. That means capital A is equals to capital B is equals to capital C. And equilateral triangle is getting formed, which is 60 degree, pi by 3. So sine square, this is 3 sine square pi by 3. So 3 sine 60 degrees root 3 by 2 whole square. So 3 by 4. So 9 by 4, where are you? Are you sitting inside option B? Then we have ticked it. Okay? Alright. Clear everyone? Yes? Alright, let's understand the properties of determinant now. Okay? Alright. So, if at all, upper triangular matrix, can you see this is upper triangular matrix? Because I know diagonal elements, all the elements below diagonal elements is becoming 0, upper triangular. All the elements above triangular elements, above diagonal, 0. Okay. So, in that case, determinant value will be what? Product of the diagonal elements. Okay. This is a shortcut or trick. You don't need to open it. Okay, ma'am. What's the next property? Next property says the determinant. Okay, the next property is very easy. The next property says that determinant value of a matrix and its transpose are equal. Basically, delta and delta dash or delta transpose for that matter is equal. Okay, so this is what the next property is. All right. Now I can see that delta 1 minus 1, 2, 4. Delta 2 is actually, can you see delta 2 is transpose of this? Minus 1, 2, 4, minus 1, 2, 4. 5 minus 3, 9, 5 minus 3, 9. 6, 7 minus 8, 6, 7 minus. So we know that these two values will be equal. Delta 1 and delta 2 would be equal. Option C is absolutely right. Okay. Are you able to follow me? Yes. Transpose property crystal clear. What is the next property? Next property says that if at all any two rows or any two columns become equal, then the value of determinant becomes 0. Very easy property. Okay. So the moment you see two columns, two rows equal, just right away you have to write a 0. And one more thing, if at all any row or any column becomes 0, then also your value of determinant becomes 0. Another property, right? Okay. All right. Yes. Now this is very interesting property. If you are changing, suppose you have A, B, C, D, E, F, G, H, I, and now you are feeling that, ma'am, A, B, C should not be on top. I want that A, B, C should be in middle and D, E, F should be above. Basically, you are interchanging these two, row 1 and row 2. So, if any two rows, if at all they are interchanged, or any two columns, if they are interchanged, then what will happen? This is del 1, this is del 2. So, del 2 will be equals to minus del 1. This is minus del 1. Okay. The value will get multiplied with a negative sign. So, if you interchange any row, just multiply with a negative sign. If you interchange any column also, you have to multiply with the negative sign. Okay. Are you getting it? Yes. Let's understand this question. Okay. All right. This question, let's see. Yes, adjoint will do. Wait for it, huh? Some people have not waited for adjoint and then they have gone, but yes, we'll do it. Okay, so I can see there is some similarity between del 1 and del 2. First thing which I want to do is del 2. I will try to actually match del 2 with del 1. My idea is that how can I become very close to del 1, similar to del 1. So, first thing is, ma'am, 1, 1, 1, 1, 1, 1. So, first of all, we know that even if I take transpose of this determinant, the value will not change. So, rather than 1, 1, 1, I'll write 1, 1, 1 over here, A, B, C over here, and B, C, C, A, and A, B over here. Okay, this is your del 2. Now, one thing which I can see is this is not having A, this is not having B, this is not having C. So, what I'm going to do is I will be multiplying A in column number 1. Okay. So let's multiply A in column number 1. And you know what? Understand. You can't randomly multiply. Basically, I am multiplying A in this determinant too. So A I'll be multiplying. Okay, so I am multiplying A, B and C, all three terms together in this determinant. But you know what? Multiplication of a constant in a determinant is very different from multiplication of a scalar in matrix. Okay, in matrix, if you are multiplying any number, you have to multiply it with each and every element. But in determinant, if you have to multiply any constant, okay, all you have to do is you have to just pick one row or one column and just multiply. So if I want to multiply A inside this determinant, I have to pick a column or a row. I am picking this one because I can see if I multiply A over here. So this is A square, this is A, B, C. Okay, now here can you see in column number 2 there is a need of B. So I'll be multiplying B. So B, B square, A, B, C. I will be multiplying C, C square, A, B, C. Correct? Okay, so I have multiplied A, B, C both the sides. Okay. Now what I'm going to do is, I am going to take something common. The moment, see, understand. If you are multiplying a constant in a row and it is getting multiplied with whole determinant, then the reverse is also possible. What does that mean? If I want to take common, I want to take common A, B, C from row number 3. So A, B, C will come common, A, B, C will come common, A, B, C will come common. And you know what? Just from single row you can take common. Are you understanding my point? Yes? Okay. See, understand. If it is 3, 9, 3, 1, 2, 7, 1, 1, 5, 0. Okay. So if you want to take common, so just 3 will be outside. From just one column or one row you can take common and this will be fine. Okay. That's it. This is determinant. But if you want to take common from a matrix, then you have to take common from each and every element. That's the difference between matrix and determinant. I hope you are getting it. So ABC cancel now. Del 2 is what? A, B, C. Okay, del 2. Everyone, what is del 2? What I am trying to do is, I am trying to create del 2 in such a way that it will become very close to del 1. Okay. So now this is A, B, C, A square, B square, C square and 1, 1, 1. Okay, now I think the del 1 and del 2 looks very close to each other. It's just that I want one and I want to switch basically, right? So I want R3 and R1 to get interchange. So del 2 will be equals to, but negative sign will come into the picture. Remember the properties. So it will be 1, 1, 1. A, B, C, A square, B square, C square. Now again one more time I want A, B, C to go in row number 2 and A square, B square. So one more time, so there will be one more negative sign because I want R2 and R3 interchange. So it will be positive now 1, 1, 1, A, B, C. Can you see how beautifully eventually del 2 and del 1 were equal? We don't even know. Option C is absolutely right. Have a look. Let me know. This is a very interesting question. Yes, hi dangerous, hi enemy. Okay. All right, everybody. Yes. Okay. I don't know. What's this? This is one hidden slide which was kept. Even I have no idea what's this. Just enroll in this crash course feeling super confident already. Okay. Are these your comments, by the way? Crash course. Okay. Everything notes, PYQ. Best decision ever. Okay. These are the comments you guys are writing. So confident. Okay. These are the comments you guys are writing. Okay. So just wanted to share with you. I don't know whoever have wrote it. You can claim your ID also, huh? Chalo. Now some very important properties alert. Come back. JEE main important things are going to happen right away, right now. Okay. Properties of determinant says that suppose, now this is where things come. Okay. Suppose any constant is stuck inside the determinant of Ka. So you have to take that constant out and it will be K power n. You must be thinking, ma'am, why is it happening? Because of the same fact that determinant and matrices, there is a huge difference in property. In matrix, okay, in matrix, single, if you are multiplying single scalar, K is single over here, right? You have multiplied K single in matrix, but it is getting multiplied with all the elements. But now when determinant is there, and now you have to take common, so you'll be like, every row is having k, 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 k. So K will come out from row number 1, it will be K. K will come out from row number 2, it will be K. K will be come out from, so K cube. So if there are 3 rows, then there will be K power n. Okay, this is how it is. Okay, chalo, let's do one question based on it so that you understand it better. A and B are square matrix of order A. Determinant A3, determinant B5. Find the value of determinant 2A. Understand it very, very nicely. And B. Okay? Understand it very, very nicely. Determinant value into B matrix. See, understand. This is A and B are square matrix. B here is matrix. See, let's forget about this. B is matrix, but what about this? This is a determinant. This is matrix. This is determinant. Determinant is value. Determinant is value. This is a JEE main PYQ, by the way. Very important. Determinant is a value. Determinant is a constant. So I am going to treat this thing as a constant. And you know what? If constant is there inside determinant, it will come out, but it will be power n. N is order. So this is determinant 2A will come out and order n will be there. Okay, because this was a constant. Now, determinant B will remain inside. Okay. Now, one more time, see, if I talk about determinant of 2A, correct? Now, again, let's treat it as a different thing. So, this is, don't you think determinant Ka is equals to K power n, determinant A, same thing, 2 power n determinant A. So, this is going to be what? 2 power n determinant A. Okay, and over here we have power n, determinant B is right there, correct? 2 power n into n, 2 power n square, determinant A power n, determinant B. Let's solve it. 2 power n square, determinant A is 3 power n and determinant B is 5. This is what you're going to get. 2 power n square, yes ma'am, spotted. 5 is right here, yes ma'am, spotted. 3 power n, spotted. Option D. Very good question, which will like clear your concepts, crystal clear your concepts. Okay? Yes? Give me a big thumbs up, huh? Stop sleeping, come on. Give me a big thumbs up. Okay? Shall I give you one easy question? Okay. Determinant A is -1 and determinant B is 3. Find the value of determinant of 3AB if A and B are having order 3. Quickly in the chat box. Now I want a prompt answer from you all. Everybody. So ma'am, you just told us that 3 can come out. So 3 will be, but 3 will have power n. N here is 3. Determinant A and B. Now one more property which I forgot to tell you, but I thought it should be quite intuitive, that you can separate out this. Determinant AB is determinant A, determinant B. Very easy property. So this is -1 and this is 3. So this is going to be 81, -81, right? Yes? Okay, easy na? What do you think? Easy or not easy? Tell me. Okay. All right. Now there is one thing, one property I would like to tell you. See, which is this property. Okay. Very important. I think king. It should be called as king property of determinant. King property of determinant. Okay. And then we'll be doing one short questions, which every year if you see one question will be there based on property of determinant, in which you have to solve the big determinant. Okay. And I'm going to tell you that what exactly one template property is applicable in every JEE in PYQ. Okay. So over here, basically, suppose you are seeing a determinant. Okay. Suppose you're seeing a determinant and that determinant looks very heavy. You can't open that determinant right away. Sometimes it happens, no? Determinant is looking, you are seeing the determinant, you'll be like, if I'm going to open the determinant, I will have to like leave everything aside. I have to become a monk and then I am going to solve that determinant. Huh? Because I can't do anything apart from solving that determinant. So to solve such questions, this is the property where the determinant looks very heavy and you have to, before opening, you need some help. You need some reduction of that determinant. Okay. So basically, this property is used when you have to reduce the determinant, simplify the determinant. Okay. What is this property? This property says that you can apply row and column operation. And let me tell you, popular row operation. Okay. Popular row operation. Okay, you will find me if you go and check now. If you go and check my problem solving sessions, go and check. Okay, determinants. If wherever I am teaching you determinant, I will be applying this property, and this property is row. This property. Let me tell you. So I'll be keeping row 3 intact. Yes. So row 1, row 3 intact. So row 1 goes to row 1 minus row 3 and row 2 also goes to row 2 minus row 3. Two parallel operations I am going to apply. Okay. So basically what we are going to do is to reduce, first of all, to reduce a determinant, we can apply any row or column operation. What is this row or column operation? So row or column operation says that you can just pick R1. R1 goes to R1 plus PR2 plus QR3. Basically, we are changing R1 with the help of R1 plus your other rows. Okay, this is a generic operation. This is generic operation which is allowed. Okay, generic operation, generic property. But out of this now understand. Out of this is a so popular. Every question will do this. Here what we are doing is understand we are changing R1 and R2 but we are not changing R3. So we keep one row. You can apply another also. You will be like, ma'am, I want to keep R1 intact. Doesn't matter. Same answer you will get. But right now you have to keep R3 same. R3 unchanged. Okay. R3 should be unchanged. And these two operations. R1, R2 you are changing. R1 goes to R1 minus R3 with the help of unchanged thing you are going to change. R1 goes to R1 minus R3, R2 goes to R2 minus R3. Okay, now this is the JEE main PYQ I was talking about. This is your function. Fx is given and this we have to figure out. Now again, can you see right now if I am going to open this determinant, it will take me a lot of time. I have to become Baba. I have to become Sadhvi. Oh, I am leaving everything. I won't eat anything. I won't feel happy. I will just open this determinant. Okay. But you know what? This property will come to the rescue when R1 goes to R1 minus R3 and R2 goes to R2 minus R3. Let's solve it. And Fx and your determinant will not even change. This property you can apply and your value of determinant will not get changed. That's the property. Okay. So R1 will become what? R1 minus R3. Let's subtract. This is R1, this is R3. So your R1, this is new R1, will become R1 minus R3. So R1 minus R3. So now subtract. 2 cos power 4, 2 cos power 4, if you subtract 0. 2 sine power 4 minus 3 minus 2 sine, so this cancel, minus 3. Are you able to subtract? This minus this will give you just 3. Can you see? R1 became very super easy. Now R2, row number 2. Row number 2, new row number 2 you will get when you subtract R2 minus R3. So this minus this will give you 3. This minus this will give you minus 3. This minus this will give you 0. This is 2 cos power 4. This is 3 plus 2 sine power 4 and sine square 2x. This is what you're getting, okay? This is fx. Now you can open it basically. Let's open this, okay? So 0, multiply whatever, you're going to get 0, plus 3, now 3, okay? So 3, it is there, plus 3, now this is minus 3 sine square 2x. And minus 0. Plus 3, it is going to give you now 3 into this. So 9 plus 6 sine power 4. Okay, this minus plus 6 cos power 4. This is your f of x. So let's solve f of x now. Okay, 3 will come out actually. So let's take 3 common. In fact, 9 will come out. Let's take 9 common. So this is minus sine square 2x. Okay. Now if 3 is gone, this is what? If you have taken out 3, so this is plus 3. What about this? 3 is gone, this is 2. And this is sine power 4 plus cos power 4. Anybody in the chat box who knows the formula? Sine power 4 plus cos power 4 is nothing but 1 minus 2 sine square cos square. Okay. So 1 minus 2 sine square cos square. Now multiply 2 by 2 so that you get 1 minus sine square 2x by 4. Okay. So this is what? So 3 is right there. Plus 2, this is 1 minus sine square x, sine square, sorry, this is 2. Sine square 2x by 2. Can you see that this minus sign and this is minus kya? This was minus, correct? Minus 3. Is it minus? Yes. Okay, anyway, this is negative again. Now this is plus. So this is this minus this. It is a plus sign. Some negative positive should get oops, this is positive now. Correct. This is positive. This will get cancelled out with this, and clearly f of x is coming out as constant. If fx is coming out as constant, f dash x will be 0. So now f dash 0 will be 0. Option A is absolutely right. Okay? Yes? Everybody getting it? Correcto? So this is, understand, to open such, especially such determinants where so many things are equal. Can you see? You will find that, okay, there is some, in column number 1, cos power 4, cos power 4, cos power 4. In column number 2, sine power 4, sine power 4, sine power 4. And in column number 3, sine square 2x, sine square 2x, sine square 2x. So in such cases, this operation will work like wonders for you. Okay, everybody? Yes? Alright. Now, can you see this? Again, another question, but same operation will same operation will save you. Okay? So, again, this is a determinant and this is the value. Okay? No shit is given in this question, direct. So, you have to just solve this determinant. But right now, if you're going to open this determinant in this situation, now you will be frustrated. Trust me. You try it, you will not get anything. Okay? So, all you have to do is, first of all, before opening, make this determinant ready to open and ready for this. Okay? So, now what we are going to do is, I can see alpha, beta, gamma. Okay? Alpha, beta, gamma. Okay, anyway, it is 0. So this is A, B and gamma, right? A, B and gamma. So let me keep A, B and gamma over here, and let me now keep alpha, beta, C over here. Is it A, B, C or alpha, beta, C? So it is alpha, beta, A, B, gamma on the first side. This is A, beta and C, alpha, B and C. Yes, this looks clear. Okay. Now what I'm going to do is, I am going to, or no need of this also, but yes, we can do that. I am going to again do the same thing. R1 goes to R1 minus R3. Let's do that one by one, so one step at a time. So this is going to be A minus alpha. This is going to be 0 and gamma minus C. Can you see that A minus alpha I need and gamma minus C also I need? So little bit happening, okay? And together R2 goes to R2 minus R3 also we can do. So now A minus alpha here also, beta minus B here also. See, beta minus B I wanted, and this is 0 again. And this is alpha, B and C, which is going to give you 0. Now is the time. Now is the time you should open this determinant, okay? This is very popular question, trust me. It has come in JEE Advanced, then it was there. Very popular question. Almost in each and every work you will find this question, okay? Now open it very carefully. So ma'am, A minus alpha, okay? This minus this. So beta minus, so it is going to be beta minus B into C. Okay, 0 is already there. Plus it is gamma minus C, okay, gamma minus C, and it is this minus this, okay, which is alpha beta minus B, okay, this minus this, sorry. So B A minus alpha and minus alpha beta minus B, okay. All right, now please understand, we don't have to, please understand, you don't have to multiply it. No, we have to keep this A minus alpha, beta minus B, everything I want as it is. It's just that one thing, just focus on whatever is given. Don't you think alpha minus A, beta minus B and gamma minus C should be in denominator? So I will divide the whole equation by alpha minus A, beta minus B and gamma minus C. After that, my equation will be right away readily in this format. Okay, just divide. Okay, ma'am. So first thing is going to get first expression. This is my first expression, right? A minus alpha, alpha minus A. If you divide, you will get a minus 1. Okay, negative sign is there. Let's keep negative. This minus. Beta minus B divided by beta minus B gone, and this is C. So minus C upon gamma minus C is what we are getting. Okay, done, done, done. Correct. Second expression is this. These three are my second expression. Again, you have to divide. Gamma minus C gone. Okay. This and this again negative sign. So minus B upon beta minus B is right there. Third equation, right? So in this third thing, gamma minus C again cancelled, and this is beta minus B, correct? Wo bhi cancel. So minus alpha upon alpha minus A will be right there. Is equals to 0. Now one thing I can do, I can just remove my minus sign and just rewrite this expression. Now we have got C upon gamma minus C plus D upon gamma beta minus B plus alpha upon alpha minus A is equals to 0. Now you know what, ma'am, one thing, everything is fine, but the numerators are not matching, isn't it? Numerators are not matching. So for that, very easy step we need to do. Do not worry about it. All you have to do is see. Not matching. So just do minus gamma and plus gamma. Here do minus beta plus beta. And here minus A plus A. Now let's see. C minus gamma upon gamma minus C. Ma'am, minus 1 plus gamma upon gamma minus C. Can you see this expression you have got? Thumbs up. Now beta minus B upon beta B minus beta upon, so this is minus 1 plus beta. Okay, hold on, ma'am. No, don't do this. Because we need this only, na. So don't do minus beta plus beta over here. This to ma'am I want exactly like this. This is already ready-made for us. Plus B upon beta minus B. Now this, yes ma'am, 1 plus A upon alpha minus A. So can you see? And this is 0. Minus 1 and plus 1 getting cancelled. Can you see? A upon alpha minus A, yes ma'am. B upon beta minus C, yes ma'am. Gamma upon gamma. Oh. What is happening, ma'am? Not a very difficult question. If you have done such question, then it will come easy to you. Okay. But if you have not done such type of question, then you will be like, ma'am, what are you doing? What are you even doing? Okay. So make sure you practice such questions. Okay. Yes. Differentiation of determinants. Differentiation of determinants. Okay. Suppose a determinant is given to you, right? And you have to differentiate that. So all you have to do is you can differentiate along row wise or column wise. Let's see, very simple step. I think differentiation of differentiation is the easiest thing in the determinant. Okay. So just differentiate. Okay. So you'll pick first row, differentiate first row, rest two row will remain same, will rest. Plus apply positive sign. Now new determinant here, row 1 and row 3 will rest, but row 2 will get differentiated. Plus now this time the third row will be differentiated and row 1, row 2 will be same. Okay, this is how it has to be done. Alright everyone? Yes? Okay, so this is how it is going to be there. Now, let's come back to matrix. Okay, because see, matrices determinants are one thing only. Let's come back to matrix. Now we will have only two topics to deal with, right? Let me check. Yes. One is properties of adjoint, which is so important. Short question is going to be there in JEE Main 2026, everyone. And the second concept which we are going to deal with is nothing but, yes, Cramer's rule. Okay. So how many of you are ready for it? How many of you are ready for it? Yes? Okay. How many of you are ready for it? Adjoint of a matrix. Yes, everyone? Ready? Okay, let's see. Adjoint of a matrix, correct? Correctamundo. Okay, what is the adjoint of a matrix? How do you get adjoint? So understand. So first of all, you have a matrix. Okay, and now you have cofactor matrix. C11, C12, C21, C22. This is A11, A12, A21, A22. Now you have to take transpose of this cofactor matrix so that it will become C11, C12 and C21, C22, and this is nothing but adjoint of A. And the very first thing we are going to see over here is how A and adjoint A, if I multiply it together, okay, very important property, multiply. So ma'am, row 1, column 1. So A11, C11, A12, C12. See, A11, C11 plus A12, C12. Okay. Now this and this. Can you see this is elements of first row is getting multiplied with elements of second row. Property of cofactor. If element of row 1 is getting multiplied with other cofactor, you are going to get 0. If element of the same, what will you get? Element of same row will getting multiplied with same cofactor, you are going to get determinant A. Same, here also 0, here determinant A. Okay, this is your matrix. So A into adjoint of A, my dear students, is nothing but what? Determinant A, 0, 0, determinant A. Now, let's take out determinant A common. This is a matrix, right? So, matrix say how to take common. It should be there in each and every element. Then only you can take common. This is a 1, 0, 0, 1. So this is determinant A into I. Very important and very important property. Base property of all the property. Bap of all the property. God of all the properties of adjoint. A times adjoint A is nothing but determinant A into identity matrix. Yes. Now you know how did this property came. Everyone getting it? Yes. Now there are a couple of properties that I want all of you to remember, and I will tell you also. See how to get these properties, right? See, A into adjoint A is equals to determinant A into I. Correct? Okay. All right. Now let's do one thing. Let's take determinant both the sides. So A into adjoint A is equals to determinant of determinant A into I. Correct? Taking determinant both the sides. Can we do that? Now understand. Let's apply the properties. Two matrix. Adjoint A is a matrix only, right? Two matrix. See, determinant AB is nothing but determinant A, determinant B. Remember? So this is determinant A, determinant adjoint of A. Yes, ma'am. Got it. Now here, understand. Determinant of this is a constant. So which property? Determinant Ka will be equals to K power n determinant A. So this will come out. But this will be treated as a constant. So constant will come out only when we can apply the power. And this is determinant I. You know determinant I is 1. So determinant adjoint of A, everybody. Determinant A power n minus 1. This is the property. Very important. Okay. So first property, what you have to remember, everybody? Yes? Tell me. Tell me, everyone. Okay. So first property, A into adjoint A is determinant A into identity matrix. Here, determinant of adjoint A is determinant A power n minus 1. Very important. Very important. Okay. Next property directly. Adjoint of A. When there is two times. See, single adjoint A, that means determinant A power n minus 1. Double adjoint, so determinant A power n minus 1 whole square. N minus 1 square. Okay. Right. Okie dokie. Yes. All righty. So this is what the second property will look like. Okay. All right. Now one more property I would like to add, and that property is fourth property. Suppose you have adjoint K times adjoint A. So answer would be determinant A power n minus 1 power K. Okay. So first, third and fourth, same property, right? Same property. Okay. Now, short question will be there from this property, but you know what? Let us do some remaining property also. But let me tell you that whatever I told you, those properties are so important. Okay. Adjoint of A transpose, adjoint A whole transpose. Okay. Adjoint KA, K you can take it out, K power n minus 1 into adjoint A. Again, adjoint A power m will be adjoint A power m. Adjoint AB is nothing but adjoint B, adjoint A reversal property. Let's not forget this is a reversal property. Okay. Let's super speed may we have studied. Now let's focus on the problem solving. Okay. Focus on problem solving, everyone. So this is right here. Okay. If A is a square matrix of order n, okay, A is a square matrix of order n, then determinant of adjoint, so we to have done ma'am 2 times. So determinant A n minus 1 square. So ma'am option D, JEE Main 2019. Option D. Right? Okay. All right. Chalo, are we ready for the next question, by the way? Ready for the next question? Yes? Ready for the next question. Okay. This is the next question. Correct? JEE Main 2025 PYQ. Let's do this question. And then I will share a ninja style also of doing such. A belongs to R and capital A will this. Determinant A is given as 4. Okay, let's do it here. Determinant A is equals to minus 4. A plus I is also given to you, by the way. So hold on, let me calculate A matrix. Okay, minus I. Okay, A matrix will be what? This minus I. So 1, A, 1, 2, 1, 0, A, 1, 2. A is nothing but what? 0, A, 1, 2 minus 0, 2, 0, 0. Okay, this is A, then 1, then 1. Correct? This is your A. Now let's find out determinant A. So it will be 0. So this is minus A. Correct? 2. And this is plus 1. And this is 2. So this is 2 minus 2A is equals to minus 4. Correct? So A is going to be 3 from here. Correct or not? 6 is equals to 2A. A is coming out as 3. Now what they are asking, let's see. Determinant of 3 plus 1, 4. 4 times adjoint of 3 minus 1, 2A. Oh, this is what they are asking, and they are saying that this is 2 power m, 3 power n. Okay? Getting it, everyone? Alright. Now we know that if any constant stuck inside a determinant, it will come out, but the power will be order of the. So 4 power n, 4 power 3. Determinant of adjoint of 2A. Okay, this is 4 power 3 will be 2 power 6. 2 power 6. Now, understand the property. Determinant of adjoint of anything will be A power determinant A n minus 1. Correct? So, here it will be determinant 2A power n minus 1. N here is 3. 3 minus 1, 2. So, 2 power 6. Correct? And this is determinant of 2A whole square. 2 power 6. Now this 2 will come out and 2 will again have. Remember that property determinant Ka is equals to K power n determinant A. So this 2 will have power 3. But you know what? 2 is already having power 2. So it will be 2 cube power square was already there. And this is determinant A square. So now this will be 2 power 6. 2 power 6. Determinant A, where are you? So determinant A is minus 4. So minus 4 square. Minus 4 square is nothing but 2 power 4. So 2 power 6 plus 6, 12. And 12 plus 4 is 16 and 3 power 0. Is it? Yes, is it? Can you see that m over here is 16 and n is 0. So 16 plus 0 is coming out as 16. Option D is absolutely correct. Yes, everyone? Tell me. Yes, JEE Main 2025, properties of adjoint. Everyone getting it? Shall we start the next question as well? Okay. Okay, let's see. Determinant A is 5 and one more thing is given 2 times adjoint of 3A adjoint of 2A. Okay, understand now. This over here is a matrix. Let us mark it as B. So here 2 adjoint 3B is given. Okay. Alright. See, understand. Now I'll start giving you some shortcuts also. This order 3. So 2 will come out. It will be 2 cube. Determinant adjoint 3B. When there is a order 3 matrix, just remove one adjoint and apply a square. Why? Because determinant of adjoint of A is determinant A power n minus 1, 3 minus 1 is 2. I hope you're getting it. This is the property I'm talking about. Okay, so just remove adjoint and apply square. Same thing, na? Yes. So this is 2 cube. and determinant 3b whole square. Now 2 cube. 3 will come out. It will become cube, correct? 3 cube, but don't forget square. So 3 cube and square. And this is determinant b square. So determinant b square. So this is 2 cube, 3 power 6 and determinant b. Where is determinant b? A adjoint 2a square. Right? Okay. So 2 power 3 and 3 power 6. Okay. Now this is determinant a and adjoint 2a square is already there. And you know what? Now 2 power 3, 3 power 6, determinant a and determinant adjoint 2a is isolated. Square is already there. So 2 cube, 3 power 6. Determinant a, where are you? 5 square. And you know what? I told you, remove adjoint and apply square. So it will become 4. Determinant 2a power 4. So 2 cube, 3 power 6, 5 square. This 2 will come out. Power will be 3. 4 is already there. So 2 cube and power 4. And this is determinant a power 4. So eventually 2 cube and 2 power 12. 2 power 15. 3 power 6. 5 square. And 5 power 4. So now understand what is alpha. This is equal to, right? Alpha over here is 15. Beta is 6. And 5 power gamma. Gamma over here is 6. Okay. So now alpha plus beta plus gamma will be what? 15 plus 12. 27, my dear students. Yes? Are you watching it? Are you with me? Huh? Please don't... I feel that this was a question from... Not from... This is a JEE 2025 PYQ, by the way. Something happened over here. The years got a little shuffled up. Okay. Yes. So this is a JEE 2025 PYQ. Imagine. Right. So 27. Yes, everyone. Okay. Chalo, one more question, because see, adjoint questions will be there. Bhar ke it will be there. Okay. Adjoint questions will be there. Now this is an inverse question. Okay, this is a very good question. JEE 2025 PYQ, a very good question. Trust me, you have to do it. Chalo, let's do it with me. I be the identity matrix, A is given, determinant A is -1. Okay, I can clearly see that one NTA has given one thing, that A is given, lambda is missing and determinant is given. So I think lambda so we can calculate. Come on. Everyone, lambda yes or no? Can we calculate lambda? So lambda value is going to be 3. Okay, I know that. So lambda 2, 3, 4, 5, 6, 7 minus 1, 2. And this is -1. If you open it, your lambda will be 3. Let's not focus on lambda because the question, our focus is slightly different. Okay, this so you everybody will calculate. Now, B be the inverse of this. See, understand. B is inverse of this matrix, which is A adjoint A square. Okay. And what they are saying is mod of lambda B plus 1 is equals to what? Okay. So mod of lambda B plus 1. For that, I will need a couple of things, a couple of formulas. Okay. Let me tell you. Inverse of a matrix, right? Inverse of a matrix. Inverse of a matrix. What is inverse? See, now that you know adjoint. So inverse of a matrix is nothing but A inverse is equals to adjoint A upon determinant A. We'll use it. Okay, we'll use it. A inverse is equals to adjoint A upon determinant A. Correct? Alright, let us come back. Okay. So B is inverse of this matrix. Correct? B is inverse of this matrix. And also one more thing I would like to tell you. If A is inverse of B, that means B is inverse of A. And you know what? AB is equals to BA is equals to I. This is all. This is now one student is coming towards the end of the session and asking, ma'am, is this chapter scoring? Come on, this is the highest weighted chapter which will change your game of JEE main mathematics. Okay, this is that important, that scoring. Now what will you do? Tell me. If I'm going to tell you that this is scoring, what will you do? Navish, what's the next? You are asking something, that means you must be having something in your brain that okay, if this is scoring, I'm going to do that. Yes? So B is inverse of this particular thing, okay? So over here, can I just write one thing? B is inverse, so this is inverse, correct? So can I just do one thing? Can I just write that B inverse is equals to A adjoint A square? Okay? Alright, can I write? Why we are doing that? Because you know what? One property. See, what is the basic property? See, if you forget anything, if you're not able to do anything, I am telling you one basic NCERT level property can save you, which is A times adjoint A is equals to determinant A into I. Remember this property? And you know what? If I replace A by A square, what will happen? A square adjoint A square is equals to determinant A square I. But just replace A by determinant A. So what I am thinking over here is, why don't I do one thing? I just multiply A both the sides. Let's multiply A both the sides. And you know what? Let's take this A into adjoint inverse of a matrix. You're looking for inverse of this. Let's just mark this matrix as C. So C over here is A adjoint A square. Okay. Now what I'm going to do is I'm going to multiply, pre-multiply A here, A here. So AC will be equals to A square adjoint A square. Okay. And AC, so that I can apply this property, which is what? Determinant A square into I. Determinant A, where are you? -1. So AC actually is coming out as I. AC coming out as I, that means A and C are inverse of each other. A and C are inverse of each other. Okay, A and C are inverse of each other. So basically C is nothing but, from this I can write C is A inverse. B inverse and A inverse are equal, that means B and A are also equal. Are you getting my point? C is equals to A inverse. Now B inverse is this C, which is A inverse. B and A are equal or not? B is equals to, actually, oh, hold on. I think there is some mistake over here. Inverse of the matrix, this. Oops. Inverse of the matrix, there is one thing which is missing here. Adjoint. Okay, adjoint. Inverse of the matrix, this. Adjoint is also there. Adjoint is also there. Yes. Now it's correct. So this is what? Adjoint of C. Adjoint of C. So adjoint of C. So adjoint of A inverse. Right. So B inverse is adjoint of A inverse. Okay. And you know what? Using the properties of inverse, you know what? Inverse and transpose have same properties. Remember, adjoint of A transpose is equals to adjoint of A whole transpose. Same. Adjoint of A inverse is equals to adjoint of A whole inverse. Okay. So adjoint of A inverse will be adjoint of A whole inverse. That means B inverse and adjoint of A inverse are same. So from here we can say that B is nothing but adjoint of A. Okay. So now here determinant of lambda, everybody, 3 times adjoint of A plus, this is not 1, this is I, and determinant close. Hold on. So we have to figure out 3 adjoint of A plus I. Correct? This is what we need to calculate. Okay. Now how to calculate this? Again, there is a challenge over here. Okay, there is a challenge over here. How to calculate? Because ma'am, adjoint A individually, so I am not aware. All I am aware is with A times adjoint of A. So let's talk about A times adjoint of A. A times adjoint of A is determinant A into I. Correct? A times adjoint of A is determinant A into I. All right. Now let's do one thing. Let's add. So determinant A. Where is determinant A? Determinant A is given, which is -1. So A times adjoint of A is equals to -I. What does that mean? A times adjoint of A plus I is equals to null matrix. Okay? A times adjoint of A plus I is equals to null matrix. Now I want to multiply 3, both the sides. Hold on. Let me just take a matrix actually. I want to talk about 3 adjoint of A plus I. This is, let's say, my P matrix. Now I am multiplying A both the sides. So 3A adjoint A plus A is equals to PA, correct? Is equals to AP. Yes. Now what I want is, I want to take determinant. See, I am looking for P. See, I know determinant P. So I am looking for determinant P. My problem is determinant P. So I am just looking for determinant P. Now take determinant both the sides. 3A adjoint A plus A is equals to determinant A determinant P. Anybody? Determinant A will be what? -1. -1. This is determinant P. What about this? A times adjoint A, everybody. So this is determinant 3. A times adjoint A, remember the property. A times adjoint A is determinant A into identity plus A. Okay. So this is determinant. So -3A plus A is equals to minus determinant P. So A minus 3I is equals to minus determinant P. So clearly determinant P you will get when you calculate minus of what? A minus 3I. So this so you have now. A matrix you have, correct? A minus 3I so you can calculate. A matrix you are having, lambda you are having. A minus 3I you can easily tricks. So just A minus 3 times I calculate that matrix. A minus 3I if you are going to calculate, you are going to get 38. So minus 38 will be your answer. So minus 38. Okay. JEE main. Yes. Okay. All right. Now I think we are done with adjoint. Just the last topic is remaining, which is Cramer's rule. Now Cramer's rule I'll be teaching in ninja style. Okay, ninja technique. You know what is it. Okay, I have made enough shorts about it. I have made one proper session for it. So yes, that we will do. So inverse of a matrix. Yes, I told you already that inverse. Okay. So if A and B are inverse of each other, AB is equals to BA is equals to identity matrix. Clearly, if B is inverse of A, then A is also inverse of B. This is the formula to find inverse of a matrix, right? Now I will give you some properties also. Properties of inverse are same as properties of transpose. So over here, A inverse is back to A. Just like A transpose is back to A. Now, very important property. Determinant of A inverse is nothing but 1 upon determinant A. Okay. Then A transpose and inverse are interchangeable, and again AB whole inverse follow reversal law. It will be B inverse, A inverse. So suppose if somebody is saying ABC inverse, so it will be C inverse, B inverse, A inverse. Okay. Right, everyone? Inverse of a 2 cross 2 matrix in ninja style. Okay. Suppose a matrix is given to you 1 2 0 9. Okay. Alright. So now A inverse, if you have to calculate, all you have to do is interchange the diagonal elements and change the sign of non-diagonal elements. Divide by determinant, which is 9 over here. This is how the shortcut works. Okay. This is adjoint of A. Adjoint you will get by interchanging diagonal and changing the sign of non-diagonal elements. Okay. Alright. So this is how it is. Inverse of a diagonal matrix, ninja style, if you want to see, suppose A is nothing but 2, 3 and 7, 0, 0, 0, 0, 0, 0, and you have to figure out A inverse, which is 1 by 2, 1 by 3, 1 by 7, 0, 0, 0, 0, 0, 0, 0. Okay? Alright? Yes? Okie dokie. And here comes the Cramer's rule. Are we ready for it? The last shot, the last thing in determinants. Okay. So we have actually crossed the 12:30, like that mark we have crossed. Okay. But anyway, all right. I think the session will be just 10 minutes more and we'll be done. Okay. All right. Now, understand that this is 3 equations. 3 equations and 3 unknowns are given to you. Right? 3 equations and 3 unknowns are given to you and you have to solve it. So, you should be familiar with 3 determinants. Okay. What are these 3 determinants? Determinant del, del x and del y, del z. Okay. So, del will be formed by coefficient of, can you see, x, y, z, a1, b1, c1, a2, b2, c2 and a3, b3, c3. This is your del. Del x, del y, del z. Everybody? Yes? Okay. Del x mein all you have to do is, the first column will be replaced by d1, d2, d3 constant. Can you see what is the constant? d1, d2, d3. So first column will be replaced by this and the rest column b1, b2, b3 same, c1, c2, c3 same. In del y what is going to happen? The middle row will be d1, d2, d3 and this is same, this is same. In del z what will happen? d1, d2, d3 will be the last column and this will be same. Okay. So these are the 4 determinants you should be familiar with. Correct? Now, can you see this is nothing but 3 equations, 3 unknown. You know all 4 determinants. Okay. Now, the very first thing, whenever system of linear equation comes, you'll be like, you have to check delta. That whether delta is 0 or non-zero. If delta is non-zero, very clear that you are going to get unique solutions. That means one value of x, one value of y, one value of z you will get. Okay, how will you get? By calculating, see delta, so you have calculated na, non-zero, that means it will be some value, suppose 3, 4, whatever. Now you have to calculate del x, del y, del z and eventually divide all 3 values by delta to get x, y and z respectively. Okay, unique solution. Now less questions of unique solution you will see. So ma'am, what kind of questions we'll see? Mostly infinitely many solution is the hot trending topic. Okay, so over here infinitely many solution. So if your delta is 0 and your all the determinants, all 4 determinants are 0, that means you are having infinite solution. Okay, and if at all delta is 0 but at least one of the remaining 3 determinants, del x, del y, del z, is non-zero. One is actually saying that, hey, hello, I am not 0, what are you talking? Okay, so in that case, no solution. Okay, now you must be thinking that, ma'am, what is this? Understand, what is consistent and inconsistent? That we'll see a little later. First of all, understand del non-zero means unique. Del 0, there are 2 cases. If all are 0, infinite. If del is 0 and at least one is becoming no, I am not 0, then it is no solution. Okay. Now, consistency means some solution. 1 or infinite, I don't know. No solution means inconsistent. Consistent means some solution. Unique, infinite, one or many. Doesn't matter. Consistent means yes, some solution we are getting. So that comes under consistent. I hope you understand the definition. Okay. Now there is one question which is in JEE Main 2019, if you can see. Okay. So x plus 2y plus 2z is equals to 6. X plus 3y plus lambda z is equals to mu, and x plus y plus z is equals to 5. Okay, this is the question right here, right in front of you. Okay, and infinitely many solutions, correct? So first thing is that why don't we do one thing, delta, let's do delta 0. Okay, so when you do this is, when you do delta 0, your lambda will come as 3. You open it, your lambda will be 3. Correct? And now you need mu. To get mu, either you open del x, del y or del z. It is easier because mu is in constant, na? See, understand. You want to replace the third column by constants. That will be, so del z will be a smarter move. Because see, in del z, first two columns will be same, which are known. Why do you want unknown column over here? And this mu will come into the picture. So if you solve it, mu value will be 7. Okay, so 3 plus 7 will be 10. Now there is one ninja technique also. Ninja technique says that whenever infinitely many solution is there, na, look for arithmetic progression pattern in the coefficients. Everyone who is watching over here, can you see 1 1 1? Is it forming an AP? Yes, ma'am. 1 1 1 is an AP with 0 common difference. Now tell me, 1 2 3, is it an AP? Yes, ma'am. Arithmetic progression. Now 1 2 lambda. Now if you want this to be in arithmetic progression, your lambda should be 3 and here 5, 6 and mu. Clearly your mu should be 7. Can you see? Hence arithmetic progression will get completed and lambda will be 7. Okay. So this is the ninja technique. That if for infinite solution, your coefficients should be in arithmetic progression. Another question, okay, again that delta, so you can play, but who will tell you the shortcut? Ninja ma'am. Ninja technique says again, can you see that del minus 1, del plus 1, okay, so sorry, lambda minus 1, lambda and lambda plus 1. These are the three coefficients, okay. Then we have lambda minus 4, lambda minus 1, lambda plus 2, 3 coefficients. Then we have lambda, lambda minus 4, minus of lambda plus 2, and last 5, 7, 9. Can you see the last coefficient are already in AP? Okay, now ये जरूरी है क्या ऐसा ही होगा? Not always, but let me tell you, JEE Main 2025 April attempt, 2 questions were like that. If it is not going to happen, then we have our natural method also, right? But if at all you are seeing the pattern, then you can apply the shortcut, okay? So now see, if these 3 numbers in AP, okay, arithmetic progression, you know, the middle of double, 2 lambda is equals to sum of these two. So lambda plus 1 plus lambda minus 1. Now you know what, this is actually automatically is in arithmetic progression, and this is not giving you the value of lambda, so this is not working for us. Although it is satisfying the AP condition, but this is not giving me the value of lambda. Let's focus on the second thing, okay? So 2 times lambda minus 1, you know how AP works. Double of middle is equals to lambda minus 4 plus lambda plus 2. Okay, so this is 2 lambda minus 2 is equals to 2 lambda minus 2. Again, it is becoming equal, condition is getting satisfied, but not giving me value of lambda. Now I have high hopes for this. 2 times lambda minus 4 is equals to lambda minus lambda plus 2. Okay, so 2 lambda minus 8 is equals to minus 2. Okay, it is actually working. 2 lambda is equals to 6. Lambda is coming out as 3. So lambda is coming out as 3. So 3 square plus 3 will be your answer. 9 plus 3, 12. Where are you, D? And you know what? If you put lambda is equals to 3. If you put lambda is equals to 3. Yes, this shortcut nobody is going to give you. And you know what? If you have not checked out, I have made a lot of shorts of ninja techniques, right? You can check out in short section that Ninja Ma'am has made another ninja technique, and I have a plan of making 20-30 such techniques. Okay, subscribe to the channel, like my shorts, and also comment on my shorts. If you're going to engage more on my shorts, I'll keep on making such shortcut videos. Okay, yes. So if you put lambda is equals to 3, now understand what will happen. 3 minus 1, ma'am, 2. Then this is 3, 3, 4. Can you see? 3 minus 4, so minus 1. Then 3 minus 1, 2. 3 plus 5. Can you see? AP is then 3 minus 1 and minus 5. Can you see? If you put value of lambda, you will see every coefficient is in arithmetic progression already. Now again, coming back to ma'am, what if that this AP thing is not getting followed? है ना? What if AP thing is not getting followed? Now the method one would be what? That yes, you calculate delta equated to 0. Okay? You calculate delta x equated to 0. Delta x will not work. I think in this question you should go for del y and del z. Yes. Not even del y and del z will work. So del y is equals to 0 and del z is equals to 0 will give you value of lambda. Correct? Now again you'll be like, ma'am, calculation of two determinants is going to take much of my time. What to do? Do you have another technique? Yes, I do have another technique, but you know what? That technique is not as simple as the AP one. Yes, you'll be like, the AP technique was like 10-second techniques. Agree? This technique can take like more than 10 seconds, approximately 40-50 seconds of yours. Okay, but you can still bypass that determinant technique. Okay, if you want to. What is this technique? Let me tell you. See, this is your method number 1. Method number 1 is there. Okay, another technique, but slightly longer one. If at all you are getting such question, okay, slightly longer one. Okay, so what is that technique? That technique is that you have to write, you have to think. See, this is equation number 3. Okay, so you have to write first equation in terms of other two equations. Let me repeat. You have to write one equation in terms of other two equations. So basically, this is, suppose, equation number 3, E3. This is E2 and this is E1. So basically what I am saying is E3 is equals to A times E2 plus B times E1. This is all you have to do. Okay, so E3 will be what? 100x minus 47y plus mu z minus 212 is equals to A times, again, E2 plus B times E1. You don't need to write this. Okay, so in that case, all you have to find now is the value of A and B. Once you have A and B, then the equation will be solved. This is only valid for infinitely many solution. Let me be very, very clear about it. Okay, only for infinitely many solution I am telling you the shortcuts. So ma'am, okay, what to do? So see, understand now, you have to compare x. So here 100x, so 100 is equals to A times E2. So 5A and plus 2B. Correct? And now this is minus 47. Okay, so minus 47. You can't compare y coefficient. Okay, all you have to do, because it will come lambda. See, understand. 100 is equals to 5A plus 2B. Now minus 47 is equals to lambda A minus B. Correct? Now mu is equals to this is this. Okay, so lambda mu I don't want. I want 212 is equals to 12A plus 4B. Now you just have to solve these two equations. How are you going to do that? So let's change this now. 212. So this 212, let me write above this. So it will be divided by 4, correct? 4, or let's divide it by 2. So this is what? 212 will be 106. Okay, this is 6A plus 2B. Correct? Solve these two equations. Subtract. So 6 is equals to A. A is coming out as 6. Now the moment you put value of A as 6, what will happen? 106 minus 6 is a 36 upon 2 is equals to B. So this is 53 minus 18 is equals to B. So this is 5 and this is 35. B is 35. 6 comma 35. Correct? Now understand, minus 47 is equals to lambda A plus, minus B. So now you have everything. Minus 47 is equals to lambda A. Lambda A. 6A minus B is 35. 6A nahi, 6 lambda minus 35. So you are going to get 35 minus 47, everyone. 35. So it is going to give you 35 minus 47 is minus 12 is equals to 6 lambda. Lambda will be minus 2. Easier? Much easier? Yes, lambda is coming out as minus 2. Similarly, now mu. Mu will be equals to 3A plus B. Okay. So mu will be equals to what? 3A. A is 6. 6 3s are 18. Plus B. B, where are you? B is 35. So it is going to be mu is 53. So minus 2 and 53, what they are asking is 53 minus 4. 53 minus 4 is, plus 4, right? Plus sign, no? Because negative, negative, plus. 53 plus 4 is 57. And can you see that option A is right here? Okay? Yes. Infinitely many solution has a hack. Okay? Everyone? Getting it? One last question. And that one last question is regarding no solution, which was again asked in JEE Main 2025. Okay. So no solution says that the system of equations, this has no solution, right? So again, there is a hack over here. No solution means what? Tell me, ma'am. No solution means delta is equals to 0. So you know what? 1, 1, 1. Yes, ma'am. AP. 1, 2, 5. 1, 2, 5. Okay. Anyway, see, this is the very easy, no? 1, 1, 1, 1, 2, 5 and 1, 5 lambda. Ma'am, this will be equals to 0. Correct? No solution means delta to 0, but other two things should not be 0. You know what? Here you will get value of lambda as something. So if you calculate, see, this is not an answer because from here you will get lambda as something. So this is 2 lambda minus 10 and this is lambda minus 10, so 5 minus lambda plus this is 5 minus 2, 3 is equals to 0. So lambda minus 5 plus 3. Lambda 2 lambda minus 25. So minus 25 plus 5 minus 20. Minus 20 plus 3. So lambda is coming out as 17. Lambda is 17. So this is also wrong. Okay, lambda 17. Now what about mu? Mu will be, actually now understand. Now you don't, if I was at your place, I will do that risk taking thing. So I will be like lambda is coming out as 17. Now other determinants should not be 0. So I will be like del z should not be equals to 0, right? So it will be what? Del z, correct? So 1, 1, 1, 1, 2, 5 and 6, 9 mu. Right? The third column will be replaced by constant because this is non-zero. Now if you solve it, you will get mu not equals to 18. So from this, you will get mu not equals to something. That means C will not be equals to 0. Okay. So I would not have solved this part. I will be like, okay, lambda is 17. And you know what? In fact, let me tell you, see, this option, B option seems wrong. Why? Because you know what? This part you have to make it 0. So lambda will be equal to something. So that's why this option is wrong. Lambda not equal to, it's not making any sense. Lambda equal to something. So lambda equal to, lambda equal to, lambda equal to. Okay. So lambda, now if I omit lambda 15 because this is odd one out, or if I calculate lambda, this is also wrong because lambda is coming out as 17. Now between these two, I'll be like, okay, lambda is 17 and I know the other, because of no solution, one is equal to 0, other is not equals to 0. So between these two also I will not pick this and pick option C, and this will be done. Okay. Now let me tell you, one student is asking that class की illustration enough है only practice के लिए. No, I would say that especially for the short questions, especially for the shortest short question, this system of linear equation, Cramer's rule, one question in every shift will be there. Now tell me, if you know that this question will come in my shift and you still are being lazy and not practicing enough, what kind of student you are, what kind of JEE aspirant you are. Okay, so you think about yourself. Okay, you have to solve each and every question of JEE main past year, at least 2025. There will be 11 to 12 questions based on this topic. Do not leave any high weightage topic. That's what I'm trying to say. Do not leave any high weightage topic. So this is the highest weightage topic since so many years, and this will be there definitely. Okay, so I think enough has been said, enough has been explained. Now, yes, I think everyone, you can just go and get a good sleep, because tomorrow again at 5 o'clock we have physics, and tomorrow again at 9 o'clock we have mathematics, vector and 3D geometry, right? So we'll start at around 8:30 or 9. Let's see when Shreyas sir finishes. Okay, so accordingly we'll start. But yes, the class will be between 9 to 12, 9 to 12:30, like that. And yes, tomorrow we have, now make sure that you are dropping some good comments, okay, in the comment section, because that's what is keeping us motivated and take such sessions, create such ninja techniques. If you want more such ninja techniques, make sure, yes, every session is fulfilled. Every session has a lot of ninja techniques. You just have to come and attend, and also drop in some beautiful comments like this. Okay.